I want to ask you about the very title of your book and the idea of something from nothing. You are telling us that matter arose spontaneously out of nothing, which I find an immensely exciting idea, but many people will find it mind-boggling.
Mind-boggling and offensive. I think maybe not as offensive.
To hell with offensive, but
no,
mind-boggling.
No. Well, you're not offended, but I checked my email. It amazes me because the purpose of the book, to some extent, is to say something remarkable. And you were kind enough in the afterward to point out the analogy to Darwin, and it's pretentious to make it, perhaps, but the physicist Steven Weinberg said, science doesn't make it impossible to believe in God. It just makes it possible to not believe in God. Because until you have science, everything's a miracle. And what Darwin showed, as you said at the beginning of our discussion, is this miracle is actually plausible from basic principles of physics, chemistry, and biology. That you can produce us without a creator.
Any sufficiently advanced technology is indistinguishable from magic.
Of today's guest, Dr. Lawrence Krauss, author of so many books. To read their titles would take us to the end of the podcast. Of course, this is the #1 New York Times bestselling, A Universe from Nothing. He's written The Physics of Star Trek, and he's also written The Physics of Climate Change. So this episode is just called The Physics of Lawrence. And I want to welcome you to my podcast. It's been 3 presidential administrations since we were together, but it's good to see you.
It's really good to see you. I'm sorry in a way that it's not that we're not together in real life and just virtually, but hopefully that'll change one day too.
Yeah, you were so kind to speak at the Math for America, Simons Foundation supported project in 2012, and that's when we were last together here in UC San Diego. And in that time, a lot has happened, as I said, including multiple presidential administrations. So actually, the first question I want to ask you today, Lawrence, is that I thought that you said you would move to Canada if Donald Trump got reelected, but you're there now, and the president is Joe Biden. What gives?
It's just time lag. it's the country he helped create. But I also said, just to make it quite clear that I'm obviously not a man of my word, I also said I'd move to Canada if George W. Bush was elected.
That's right.
And I did fly to Canada right the day after that election, but I didn't stay. But it takes some time to become an expatriate. And in any case, I'd like to think that better late than never.
Right. So the books that we're going to talk about today, of course, we are going to talk about A Universe from Nothing, Multiverse, String Theory. You're a vocal, exponent and proponent of scientific reasoning, scientific thinking. You are the proprietor of the Origins podcast and the Origins Project Foundation, which has had many, many speakers, some of whom I poached. So thank you, Lawrence, for giving me the idea to get Shelley Glashow on and get Noam Chomsky on my podcast. And they're very delightful, and we get to cover different aspects of their personalities. But I do want to start with A Universe from Nothing, which is subtitled, Why Is There Something Rather Than Nothing? And I'm also going to talk about your previous book. I was about to say penultimate book, but I think you're so productive, you're probably writing with your hands right now, another book. But this book was sort of with a foreword or an afterword by Richard Dawkins. It's very surprising to me, Lawrence, again, that someone who is so well known in the humanist or atheist sort of community, that you have a dog named after the prince of the tribe of priests of the Israelite tribes. You have a dog named Levi, is that correct?
I don't know if I can do this. I'm going to try. Hold on.
Oh my gosh, we're seeing a Levite.
Yeah,
wow.
You're seeing a Levite right there, out of focus, but
there he is.
There he is.
Wow.
There he is. And he appreciates the shout out that you just gave him.
So what is the world's foremost or second foremost after Richard Dawkins, your friend? Why does the most prominent one of the most prominent atheists have a dog named after the tribes of Israel?
Well, I can give you two answers. I don't know if any of them are true, but the first answer is that I didn't choose the name.
Okay.
But the second answer is his name is Levi Krauss, right? So now you get it. Okay.
That's right. Well, he is. He's got good genes. Let me just say.
Yeah, exactly.
You know, one of my dogs doesn't behave properly, and we always say, it's bad genes. But then we have to put him.
I have a third answer too. I just occurred to me. His mother was Jewish.
That's right. Well, the Levites in the temple service they were, of course, very powerful, but they were subservient to the Kohanim, the Kohanes, the people that you meet, Cohen or Kagan, and people like that, and they would have to wash their overlords' feet. That was part of their service. So I hope Levi, your dog, will do the same to his
he
owner.
Would be very happy to wash my feet. He would be happy. He licks them, actually. There you go.
So I want to turn now to books, because you are a prolific author, and actually, the first time we almost met, we had a close encounter of the Cleveland kind. In 1993, I graduated from Case Western Reserve University, and that was the year you became chairman of the physics department. And so I think we just missed by a couple of weeks. But at the graduation, the previous chair, who I can't remember who it was, he gave all the graduates. There were only 13 of us. It's a great school. It remains a great school.
Sure.
But he gave all of us physics majors a copy of Steven Weinberg's Dreams of a Final Theory, which could not have come at worse timing, because, of course, later that year, the superconducting supercollider, which Steven was advocating for and agitating for, was canceled. I want to ask you about books. I heard you say once that you were turned on to what we call popular science by a man that I'm very fond of. And I actually have him incarnate, or perhaps in miniature form. I have a lot of puppets, Lawrence. Maybe someday you'll have a puppet. This man here. You see this guy? Do you recognize this guy?
That could be Galileo. I'm not sure.
It is Galileo.
Yeah.
It's a telescope. You see, that gave it away.
Yeah. Well, I didn't know if it was a snake he was holding, but I assumed it was a telescope.
I actually have a lot of...
I'm a big fan of Galileo's, by the way. He had a great sense of humor.
So tell me about that. I want to talk... I'm actually I've taken upon myself, with the help of Carlo Rovelli, to make the first ever audiobook version of the dialogues. That's never been done before in human history. So Carlo, myself, and a good friend of mine, Lucio Piccirillo, are recording the first ever audiobook of any of Galileo's books. It's
Italian?
What's that?
In Italian?
Yeah, professore. No, I'm not doing it in Italian. But they're English.
The other two sounded like they're Italian, so I figured maybe you could do.
Yeah, Carlo Rovelli, of course, is a renowned author and thinker, advocate of loop quantum gravity. We're going to get into all that. But let's get back to Galileo. Galileo means so much to me because he really was the first scientist. He was a popular author, and Stephen Jay Gould, in the book that I tried to get an audio version of and found, to my chagrin, it didn't exist, and then had to make it myself. Stephen Jay Gould called him one of the greatest writers of nonfiction in human history. Superior to Newton.
I've said, and you may have, if you've read things I've said many times that it upsets me that we have these great books, programs at universities, and you have to read Ulysses, but you don't have to read the dialogues. The dialogues are easier to read and funnier, certainly, I would think. So Galileo was a role model in many ways, but the reason I read about him, a book not by him, but I read a book about him, and I was 11 or 12 in grade 6, I think, and it was probably recommended in the school I was in, some enrichment program, and it really had a huge impact on me because it made me think, and I've since discovered this isn't true, but it made me think of scientists as brave individuals fighting for truth and willing to, confront, obviously, pseudoscience, superstition, whatever. And so that brave effort of his really, really resonated with me. I remember at the time thinking that, but also the notion of being the first one, to see the moons of Jupiter and changing, obviously, the way we think about the world. And in fact, one of my books, Fear of Physics, really begins with Galileo in an important way, because really, he changed everything in such an important way. We don't really give him credit. And one of the things that when I've taught, as I have over the years, I've taught many courses, standardly called Physics for Poets courses in universities. When I taught at Yale, which is where I taught right before I went to become chair at Case Western, I sort of changed it to Physics for Lawyers, because I'd met a lot of pre-law students, but I'd never met any poets in any of the classes that I taught. But I always made a point of requiring them to read Galileo because it's readable, and the utility of using the Socratic method, which he does, and with humor, but also pedagogically, there's a lot of evidence that the only way to really learn something is to confront your own misconceptions. And that's precisely the way, more or less, he teaches things. And he had great thought experiments well before Einstein. He would have had the Italian version of Gedanken experiments. And they're great. And they're wonderful, wonderful ways of realizing your own misconceptions. And I've used them. I was once in another life lecturing before many leaders of the free world, it turned out. And I asked them, I had a piece of paper and a book, and I asked which would hit the ground first. And of course they all said the book, but then I did the standard thing, which I do with class, say why, and of course many of them would say the book's heavier. And then I scrunched up the paper into a ball and let it drop. And they, and that was shocking to them, but it was really a version of what Galileo did. And so his pedagogy was great, but as a scientist, he really was. I used to say he was the father of modern science, but then I actually read a piece by his father, who was a musician, by the way.
Yeah,
Vincenzo. Yeah. And it's a great discussion of the nature of truth and empirical evidence. And I kind of realized, well, it's clear why Galileo grew up to be the way he was. His father was a passionate advocate for truth and evidence. And so I like to think of Galileo's father as the father of modern science, since Galileo was the first modern scientist.
That's right. That's his heritage, his legacy of that. Yes, his father was a musician, and then he would use things like tempo and so forth later on, influencing him, to take his pulse.
That's how he timed. And I don't know if you've been. You probably have. Then you've probably been to the museum in Florence, the sign, which I find, frankly, much more fascinating than all the other art museums in Florence. I find that museum and when you go to Florence and it's busy because you can't get into the art museums, you can always get into the Museum of Science and not only see Galileo's finger, but see the actually instruments that he used to discover the laws of motion and change the way we think about the world in a way that in some ways was not only more profound than what anyone else did, but the rest of modern science was impossible without Galileo. And Newton's first law, at least, is just sort of a natural extension of what Galileo did. And so Newton was lucky. I mean, Newton was amazing, but certainly lucky to be born a generation or two after Galileo.
Yeah. He took the mantle on the year that Galileo died, right?
Yeah.
He was born on Christmas Day, at least. Everyone always says that, Lawrence, but they don't realize that the Gregorian calendar changed. So it's actually, I think he was born on what we would call January 4th or something now. But I want to read a passage from Sidereus Nuncius, which I think is the book, that with the aid of the telescopic lever, figuratively moved the Earth more than any other scientific instrument, more than the Large Hadron Collider, more than LIGO. And I want to read it, and I want to particularly pay attention to the second half of this passage. So Galileo says in Sidereus Nuncius, the starry messenger, he says, with the aid of the spyglass, the universe may be observed so well that all the disputes that for so many generations have vexed philosophers are destroyed by visible certainty, and we are liberated from their wordy arguments. You're no fan of philosophers, if I recall correctly.
It's a bad rap. I get accused of that just for making a few jokes. But anyway, go on.
I want to get to that because when you spoke here, I got pushed back once. For the colloquium that you gave from the string theorist, you've pushed on philosophers, especially in the wake of a review by a prominent philosopher of A Universe from Nothing. What is this kind of of course Galileo and Newton were considered natural philosophers, whatever that means. It's very different from what is your beef with philosophers?
Look, I don't have really beef with it at all, but let me say that the difference, what made science was natural philosophy. So it grew out of philosophy, so there's no denying that. But then you can also say philosophy grew out of religion, but philosophy isn't religion and science isn't philosophy. Sure, we respect the legacy, but the fact, what he said in the Starry Messenger there, just by looking through a telescope, you can destroy the debates. is a great example of the difference of the scientific method, the whole methodology that he epitomized, but and also largely created, compared to, say, Aristotle, who no doubt was a wonderful philosopher and people have made me appreciate him more than I had before, but but one of the things Aristotle said is that men and women have a different number of teeth. And what Galileo could have said to him and would have said to him is, why don't you look in their mouths and count? and that's the difference. Now, so look.
But he did do something amazing, Aristotle. The only scientific thing I think that he did, Aristotle, that wasn't wrong, is he said that whales aren't fish. Now, I don't know how the hell he did that, but he did it. So,
but some people have also told me some of his biology was actually better than I'm giving credit for it. But let's not. We didn't come here to either bury or praise Aristotle. So let's get back to so philosophy. We all do philosophy, and philosophy as an endeavor, which is really logical thinking, critical analysis. I mean, it's a central part of all intellectual disciplines. So let's be clear about that. What the beef that I have is the people and I don't have a beef. Some philosophers, well, I don't even want to put it this way. The claim that you have to study philosophy to be able to do physics is just wrong. That's all. It's just empirically wrong. As I like to say, most physicists can't spell philosophy, but it's not. I mean, the more you read of any subject, the more you may appreciate your own discipline. So there's no denying that. But you simply don't have to. And most scientists don't read philosophy. Moreover, the philosophy of science, which is an interesting field, when it comes to physics, it's really irrelevant. I mean, in the sense that the questions of interest to those philosophers of science, which may be interesting intellectual questions, and I don't deny they might be, my only point is that they don't influence the progress of physics. Mm-hmm. So some of them are incredibly interesting questions, but they don't influence the progress of physics. And that's just an empirical fact. It's not an opinion. Right. It's just a fact. Now, the key point here, I think, is that when philosophy influences science the most is in a discipline where the questions aren't well framed. When the questions aren't well framed, philosophy is a wonderful discipline for helping frame good questions that drive that field forward. And a field, for example, that I would argue isn't maybe in such a state is sort of has to do with brain science, consciousness. Okay, where what is consciousness? Is a question that is very usually when you ask that, you get a vague answers at best. And so that's why there's a lot of interplay, I think, between neuroscientists and philosophers, and when it comes to brain science. And I know a few philosophers who are Dan Dennett and others who interact very strongly with neuroscientists. But in physics, the questions are well framed, and the questions, we've evolved so much since the time of Galileo that really the field, to really make progress, you have to understand the intellectual baggage of the field, which isn't philosophy.
Right.
And that's true. Now, what is interesting is that the results of physics can then be utilized later by not just philosophers, but other people to change their worldview. And that's what the universe from nothing is all about. Mm-hmm. And some people object to the fact that science changes the meaning of certain things, including nothing, the word nothing. And my answer to that is that that's just an example of learning. I mean, so science changes a lot. When I've debated with some Christian apologists, for example, classical logic may be useful, but when it comes to quantum mechanics, we often have to throw it out the window. And it's not because we want to, or we have a predilection. It's the nature is the way nature is. And in any case, I think, philosophy as a discipline is incredibly important. And I've read philosophers and they've had a great intellectual legacy, and some of the work they do in their own discipline, it may be incredibly difficult and interesting, but it just doesn't impact on the field of physics. And that's not a pejorative. That's just a fact.
One of the main characters in the greatest story ever told so far, Why Are We Here, is Plato.
Yeah.
He plays really an outsized role in that book. even more than the person we're going to turn to next. But I can't resist, because you brought up Galileo, you brought up consciousness. Galileo was also one of the first people to tackle the hard problem of consciousness, almost to no avail. But what I love,
there hasn't been much progress since, in my
exactly.
opinion.
But in physics, look at the comparison. So I like that ratio test that you were proposing as a rubric for at least assessing which problems can be attacked by rigorous, hard scientific thinking and data and evidence, and which ones may be forever locked away. Free will, as you say, and consciousness perhaps being two.
I'm not as pessimistic. I just, we have a long way to go, but I haven't seen any limits right now. I still haven't. People ask, what are the limits to science? I always say, well, if I knew, I'd have to know what the limits are, right? I mean, it's kind of crazy, but I don't see a brick wall yet. There are problems that are very hard. And people think I'm joking when I say, I've been on the stage with many biologists, when I say I do physics because it's easy, because it is easy compared to consciousness. And so it's not surprising that we've made a lot more progress, but I don't see an ultimate barrier to understanding it eventually. And maybe, I'm agnostic about that.
Mm-hmm. Yeah, and I want to talk about prospects for AI Galileo, or as I call him, AI or Galileo. We'll talk about that later. And if computers are even capable of doing such things as Galileo or Einstein did, we'll get to that later. But last direct reading from Galileo, since I can't resist, really involves what's very little known about it. He also was a great, observer of the human condition. And I believe he came up with what's known as the Dunningkruger Effect, which will segue back to a universe from nothing. So what he says in Segredo, who is the character I'm playing in dialogue, Segredo says this, it always seems to me rashness on the part of some who want to make human abilities the measure of what nature can do. On the contrary, there is not a single effect in nature, even the least that exists, such that the most ingenious theorists can arrive at a complete understanding of it. In fact, this vain presumption of understanding everything, Lawrence, can have no other basis than never understanding anything. For anyone who had experienced just once the perfect understanding of one single thing and had truly tasted how that knowledge was accomplished, he would recognize that of the infinity of other truths, he understands nothing. I want to ask you, Lawrence, have you ever understood something that you feel was sort of as high a level, a discovery that you made perhaps for the first time in human intellectual history?
Once or twice. Let me say, there are a few times I made some profound discoveries, but nature didn't choose to agree with them. They could have been right. They weren't mathematically wrong. As a theorist, as an experimentalist, you're either right or wrong based on the experiment. But as a theorist, you can propose things that are perfectly consistent, but nature may not. There was once I was sure I had the solution of what's something called the solar neutrino problem that was beautiful, but nature didn't do that. But I think the one time that I really did really feel that was when I first became convinced there was a cosmological constant, and no one believed it, and spent a few years before I even convinced, I think, my colleague and co-author Michael Turner, before we finally produced that paper in 1995, arguing that the evidence suggested that 70% of the universe was the energy of empty space, and we did it. And I must say, in some sense, it was a realization, and that I guess I felt that was the first one to kind of really appreciate that. But at the same time, to be fair, a large part of wanting to publish that was the decision that I was convinced that it was a crazy possibility, but it was the only possibility to me that agreed with all the data. So what it meant to me was that some of the data was wrong. So I really wrote that to point out that, hey, some of the cosmological data must be wrong, because if it isn't, you're driven to this insane possibility, and the insane possibility turned out to be right. So, but so that's probably for me the most explicit example of if you're a theorist, you go through these phases, almost like death of people, death of loved ones, where you, in almost every stage sometimes you're just pushing things forward a little bit, but if you're ever proposing something particularly new, you go through the stage of love, and you think, oh, this could really explain things, and then it gets moderated, and then generally the experiments show it's wrong or something, and so you go through this grief period as well. So I've had this hope many times that I might be the first one to understand things. But the dark energy was probably the most concrete example of potentially sort of being right.
And that brings us to the next stage of the conversation, which we'll get into, nothingness, etc. And this involves the beginning, not of one of your books, but of the recent book by your debate partner, Stephen C. Meyer, who is a Christian apologist. And he is he has been on the show. We have talked about his new book, Return of the God Hypothesis. I'll put a link to it right over here.
Don't bother. Don't do that disservice to your listeners.
Well, Lawrence, you know what? I actually wrote a blurb for that book, and you'll be amused why. Because he sent me this book, and in it he said, I've seen your videos, and I've had some videos critical of string theory and the multiverse and stuff. I hope we can get into. But he said, I thought you might find this book interesting, and if you wouldn't mind considering a blurb, it's got Brian Josephson, which is a controversial figure, but I thought it would be interesting to have a blurb from a guy who won the Nobel Prize, right? Who's named Brian, and then another blurb from a Brian who lost.
I see. So but anyway, that was your rationale. Okay. I was pleased to see that at least in an article he wrote afterwards that he claimed that writing that book was motivated in part by a debate he had with me in Toronto, where
You're the opening line. You're in the opening line of the book, and the book goes through basically trying to make the argument from design, essentially that two different instantiations of information lead, and he is a PhD from Cambridge in philosophy of science, just for the record. And we were talking about philosophy of science just a minute ago. But the claim that he makes is, I'll leave aside the DNA, that requires a mind, etc. But that the low entropy, starting point of the universe leads to, there aren't things in the universe that decrease entropy, according to the second law. And he goes through the Born-Guth-Vilenkin theorem. He actually does a good job explaining what that is. He talks about, alternative proposals. He gets into all sorts of mathematical Wick rotations, and he goes after Stephen Hawking in a brief history, which I've actually taken big issue with Stephen Hawking for kind of literally in that book. He says, I'm going to do a trick. Don't pay attention to it. It's just a mathematical, and he does what's called a Wick rotation, which you're very familiar with. And then all of a sudden, time has no boundary. Okay, so I think that's kind of nonsensical. No physicist nowadays.
I have my own. Stephen was an old friend of mine. I think I know why he said that. But anyway, I won't say.
And then there's also so many of these books nowadays that mention God, et cetera, the God equation, the God hypothesis. Anyway, what do you make of this notion of is it a problem that the universe seemed to start, unless you apply the Albertian, which I know you might have issues with, this past hypothesis instantiation by fiat of a low entropy state? Talk to me about what do you think of as a problem in the ordinary Big Bang, Born-Guth-Vilenkin boundary proposals? What do you think of it as a problem? Is it a problem, or people?
I think people are. First of all, I think people like Stephen Meyer are trying to point out what they think are problems because they've heard people talk about problems that aren't really problems. And by the way, I should say I've written a response to demonstrate most of his misconceptions in a called Cosmology Without Design, I think, in the magazine, which is a lovely magazine online called Inference.
Yeah, I'll put a link to that.
Edited by David Berlinski and Shelley Glashow, in fact, is the I think editor in chief of it or something. But anyway, so I tried to explain there why what the misconceptions that somehow cosmology points to design was. But look, the point is that all you need is a universe that can have from some arbitrarily microscopically small region inflation, and the rest just happens naturally. So I don't see concerns about the state before inflation are interesting. We have no evidence about them. If inflation happened, it erased that evidence, largely what happened before them. And we also know we don't have a theory of t equals 0 either. So where people start talking about problems in areas where the physics really isn't well defined, what I say is, well, okay, that's fine. Let's talk about the physics where we can understand it. And in fact, in my book, Atom, which was a history of an atom from the beginning of the universe to the end, one of my favorite books in a way.
Yeah.
I really began. I think it's useful to begin our history of the universe back to a time when both our theories and our empirical data allow us to reliably extrapolate. Before that, it's just pure speculation. I'm sure we can talk about it, but it's just words.
And when we think about, obviously a universe from nothing is making the case for some pre-existing state of the universe. The one thing that Stephen points out, and others have pointed out too, Paul Steinhardt, Einstein Professor of Natural Science at Princeton University, Neil Turok, a fellow Canadian, at least transplanted.
He's a transplant.
Yeah. And student of Stephen Hawking, right? This notion that you don't necessarily need a singularity. You don't need to have a quantum gravity. I want to ask you. I've asked this of Lenny Susskind. I've had Sir Roger Penrose on after he won the Nobel Prize. I claim I hear this Ouroboros statement, this tautological statement, which is that we need quantum gravity to understand the physics of singularities at the core of a black hole and at the origin of the universe. And then why do we need that? Because the universe began with a singularity, but there's no evidence. And as you said, the universe hides evidence of its own origin. Now, I have a vested interest in this as one of the 4 co-leaders of the Simons Observatory, looking for primordial gravitational wave B modes. My job security does depend on this, as Upton Sinclair would say.
This is an area, and as I spent many years of my life discussing those very gravitational waves as signals.
That's right.
From the beginning of time. And in fact, actually, happy to say that I was asked, as you probably know, by Physical Review Letters to write the companion piece to that paper that your book behind you is based on.
That's right.
And because I was ready, and happily, the head of your collaboration, I had all the data in advance, and so I could do that. But anyway, you're right. Look, I think the point is if we avoid a singularity, which I think is most physicists would speculate is likely, since we don't like singularities. Mm-hmm. The way to avoid it is probably a theory of quantum gravity. So in my book and in my work, but in my book in particular, I talk about what is an extremely plausible hypothesis about how and in fact, actually one that began with work when I was a graduate student, and then I chose not to publish it. And Alex Valenkin actually ended up just down the corner from me, published the paper at almost the same time. I was working with a friend of mine, Ian Affleck, on it. But plausibly, you can create a universe of finite size as a quantum fluctuation, and then you don't have to. Then you avoid that question, if you want, about the singularity. But you don't avoid the question of quantum gravity, because the creation of such a microscopic universe, non-singular but microscopic, that process is a quantum mechanical process that involves gravity. So we can speculate about its likelihood, but we can't calculate the details, if you wish, without a theory of quantum gravity. So you kind of need a theory of quantum gravity to either whether there's a singularity or not, to really frame the initial conditions of our universe, which as physicists, really, that's, more or less, once you have the initial conditions, then the rest is sort of, it's just easy in principle. But the plausibility, the fact that we know a theory of quantum, we know that space and time are the variables of gravity, and that if gravity is quantum mechanical, those two variables become quantum mechanical, and therefore, since they're quantum fluctuations, you should be able to spontaneously create space-times. That is incredibly plausible, and it's hard to imagine any theory of quantum gravity that wouldn't have such a possibility. But that's all you can do at some level, and the rest is talk. But that's all you need to do what I did in the book, really, to point out that ultimately the surprising thing, and this is where science. The intent of that book was really to discuss the revolutions that have taken place in cosmology over the last 50 years. And also certainly to hit at religion, because after evolution, the last bastion of God was in somehow creation of the universe. After you showed that you can have life without God, then the next.
But you can have evolution without
I know. Evolution doesn't. Darwin never talked. In fact, Darwin said we would never understand the origin of life.
It would be like understanding the origin of matter.
Yeah, exactly. And I've quoted it, and we're hopefully understanding the origin of matter sometime.
Yes.
But the point is that that's often held as, hey, how could you create a universe without a supernatural being? Because how could you create a universe with 100 billion galaxies, each containing 100 billion stars, a lot of stuff, if you didn't have stuff there at the beginning? And what's worth pointing out is that argument itself is just simply fallacious. Whether or not you buy the other details, as Alan talked about with inflation. You get a great free lunch. Because gravity has negative energy, you can get what apparently is something from nothing very easily. And that was a discussion I wanted to have in my book, to point that out, that you don't need something supernatural to have a universe full of stuff if there was no stuff in the beginning.
But why not?
I think that's really profoundly surprising. It certainly was. If you'd asked me in the 1970s or early 80s, I would have thought I would have said that's nonsense. But anyway.
So I'm sitting in the office, as you remember from visiting here.
Yeah.
This is the office once occupied by Jeffrey Burbidge, and his wife Margaret left some late great Margaret Burbidge. She one of the titans of astronomy of all time. She left some of these plates of from telescopes from before I was born, taken here. This is actually from 2 months before I was born, 1971.
Oh, 71.
Taken and so forth. But as you know, Jeff was a major opponent of not only of inflation but of the Big Bang itself. And in fact, he was one of the foremost proponents of the quasi-steady state universe, along with his late great colleague Sir Fred Hoyle,
who was wonderful,
who's a titanic influence on cosmology. But he used to say
and
things
also
like
wrote great science fiction, by the way.
Wonderful books.
Yeah.
He wrote once that practicing cosmologists, card-carrying cosmologists, were overwhelmed, I quote, by their in their appreciation of the Big Bang because of their love of Genesis 1:1. And I think actually your, obviously Borguth-Lincoln and inflation, Allen's work and Linday's work, Steinhardt's work, they is sort of more of a fellow traveler with the biblical narrative than is Paul Steinhardt, who has. All right, I mentioned Paul Steinhardt, but I meant in his initial incarnation as one of the founding fathers of new inflation, not in his now role as one of the most prominent anti-inflation activists, if such a thing could be imagined. So why not?
Sad.
Yeah. Well, let's get into that because he's a titanic influence on cosmology and is doing really interesting alternative work. But we'll get into that, the importance of non-mainstream voices in cosmology. But getting back to Hoyle. Hoyle thought the Big Bang was an inflation. He'd probably say the same thing, was too much like Genesis 1:1. And we cosmologists like you, Lawrence, you're overwhelmed by Genesis. You just love Genesis. But wouldn't an eternal universe, wouldn't that make more sense? In other words, where in, and I give this to Stephen Meyer, where does Hilbert space come from? Where is an instantiation of a as Sean Carroll talks about this in his talk, God is not a good theory. So where does the Hilbert space come from, and why not travel in the camp of a cyclic model like Sir Roger?
Well, first of all, the answer to where does Hilbert space come from is quite simple. We don't know. We don't know if quantum mechanics arises only in our universe or if it's a universal property of nature, and we don't. And physics, in some sense, doesn't answer those kind of questions. But I think the answer to look, first of all, it doesn't matter what people think are pretty or nice. Or a cyclic universe is very pretty, but it doesn't really matter whether it's pretty. The question is,
it's farther away from God.
Well, well, who cares whether it's far? The point is, we shouldn't be driven by our hatred or love of God. And as far as I know, no physicists are to first approximation. I mean, it is worth pointing out that the father of the Big Bang really was, he was a Catholic priest.
He was a priest. Yeah.
And Lemaitre was wonderful, but he also, when the Pope specifically said, "Hey, this validates Genesis," he wrote to the Pope and said, "No, don't say that because it's a scientific theory and you shouldn't abuse it." Yeah. But so sure, it is if there's one thing that the Catholic Church could jump up and down and say, "See, we told you so," it would be that, because it was the conventional wisdom in science before certainly 1925, say, or even before 1925, that the universe was static and eternal. That was a scientific view, and probably specifically because it wasn't Genesis. I mean, among other things, there was no evidence of any evolution of the universe. And then the Big Bang was discovered, and it demonstrated that our universe had a beginning, most likely. And the Catholic Church could rightly jump up and down and say, "See, we told you so." But of course, that's just one is just vague words. One is reality. One's got stupid stories associated with. One's got empirical evidence. But I think the bottom line is that what we've grown up to realize that our universe is not all there is, most likely. And therefore, to say that our universe had a beginning is not to suggest, what really matters now is the multiverse. Okay? that could be eternal if you don't like it. But for me, what I like better is an argument that Stephen Hawking gave, so the same thing. If let's say our universe is all there is, space and time are coupled. If space comes into existence, then time comes into existence. Okay, so there was no time before the Big Bang, and the question, what happened before the Big Bang, is simply not a good question. The whole question of causality and everything else goes out the window, because if there is no before, then the traditional notions of causality and inference that, of course, apologists and others love to jump on is a wrong question. It's like, as Richard said, I think in my book, I don't know what somewhere, what's the color of jealousy? Although we know that's green. But so I think the point is, I love the realization that we may have to just change our notions if of causality itself, if time began with the Big Bang, because there was no before, and then I love the idea that we're forced to change our notions, but I suspect more likely is that our universe had a beginning in the midst of something from which some universes are beginning right now and some universes are ending, which is a multiverse. Everything I know about theoretical physics right now suggests to me that's the most likely possibility, but I'm not wedded to it. But by the way, some people would say, of course, you can't measure your multiverse, but the wonderful thing, and I wrote a paper pointing this out, and then another paper with my friend Frank Wilczek about this, that if we did measure gravitational waves from inflation, it would demonstrate the gravities of quantum theory, but it would also in some ways give us a way of proving that there is a multiverse.
Well, I want to get into that because I read that paper and I've had Frank on to discuss that paper in the past year. But I confess I don't fully understand the quantal nature. One of my professors there, Professor Eck at Case Western, you might remember
Tom Eck, of course, yeah.
Yeah, Tom Eck.
He was his boss for a while.
Yeah, so he used to talk about, we say classical physics, so we should say quantal physics. Anyway, getting into that, when I think about a quantum mechanical experiment, all the time, we're going to talk about why there's so many theorists writing, popularizations of science, but not as many experimentalists. But whenever I hear a theorist talk about it, it's always spooky action at a distance. Like what constitutes the quantum to a theorist like you is, spooky action at a distance, or it's entanglement, or it is the double slit experiment and the many worlds and things split up. Anyway, how would Bicep 2 in the counterfactual universe where my book is winning the Nobel Prize, how in such a universe does the detection of a classical gravitational wave manifest the imprimatur of a quantum process to 381,000 years earlier?
Well, because if it's a scale invariant spectrum, then there's only one dimensional parameter that determines the intensity, if you wish, of gravitational waves, and that's in some sense the energy scale at which they're created. Okay, and what we showed, I showed in explicit calculation, and then when I talked to Frank about it, we came up with a dimensional analysis argument, which is really really kind of wonderful, which it basically shows that given that the only dimensional parameter is the scale of inflation, if you want to call it that, but the scale at which this scale invariant spectrum is created, you can show that spectrum, the power in that spectrum, vanishes in the limit where the Planck's constant vanishes. And so the whole, you can jump up and down and talk about spooky action at distance and everything else, but the point is that the finite, all of it comes down to the fact that Planck's constant, the fundamental constant of quantum mechanics, is a finite number. It affects the energy levels of atoms. It really demonstrates the quantum nature of matter and energy, or more the initial version, which is that that all states are quantized in energy levels. And if h bar, if the Planck's constant went to zero, then atoms would have a continuum of levels instead of a a finite spectrum. And it turns out, and I can show you on the blackboard pretty easily, but probably not here at the right time, but sometime I'll come there and show you.
Yeah.
By simple, literally undergraduate level dimensional analysis, that given the dimensional, and it has to be a scale invariant spectrum for this to be the case, by the way, that you can show that vanishes. And no matter how it's calculated, it will vanish in the limit where quantum mechanics goes away. So if it's there, then and it's a gravitational process, then gravity must be governed by quantum mechanics.
And would the same hold true? If I tell you I've got Johnson noise, stochastic scale invariant, I detect it in my radio receiver from
the dimensions are different.
Okay,
I'm sorry, I shouldn't interrupt, but I know. I think I know where you're heading. And the point is, it turns out you have to know that there's only two quantities. I should say there's not one dimensional quantity. If it's a gravitational process, there's another dimensional quantity, which is the gravitational constant, Newton's constant. And Newton's constant has dimensions. That's what makes it different than electromagnetism. And when you say the only two-dimensional quantities are Newton's constant, which tells you the strength of gravity, and the scale at which this thing is produced, when you combine them, you show it vanishes unless in the classical limit. But that's not true for electromagnetism. It's not true for that same dimensional analysis counting doesn't work.
Yeah, I wonder. Yeah, I wonder though if I'm wrong actually, because to get the mode counting correctly in the blackbody case, you do need to actually include the phase factor for including Planck's constant. But I guess the inference I was trying to make is if you detect a classical wave, but your point is that it's a background and stochastic. It has to have those two features. It has
to be not just as exactly. For example, we've detected classical gravitational waves from colliding black holes, but in no way does that in any way prove that gravity is a quantum theory. It's a very different kind of argument.
Right. And then the only other response I would get is that as you know, because you worked on this for decades, that there is so-called second order tensor perturbations. Anytime I had Alan Lightman on this week and I told him my favorite of all his books is a problem book in gravity and general relativity. So we talked about that for an hour. No, we didn't do that. That would be a complete waste. But I said there's a problem in there in chapter 3 where he talks about on the Massachusetts Turnpike, where you probably spent many hours of your life, a motorist is shaking his fist at another motorist, and how much gravitational wave energy does he produce? And I said, well, but I'm saying to you now, rather, that the early universe, even in the bouncing cosmological models, has a vast amount of matter and a vast amount of acceleration. And so there are second order tensor perturbations, which would produce. Yeah. So if we detect those, then those are implicitly classical. In other words, there is no quantum gravity in the cyclic or aeon model of Sir Roger or whatever. So I wonder, would there be a way, and it would produce a background. I mean, you'd see a stochastic background of gravitational waves from the metric reverberations of second order. So I wonder, is it possible to falsify it? And maybe not, but I think this has been helpful.
I think there is. I've written paper. We can talk about it. I think there are ways to falsify it by looking at a few things, the ratio of density, because those second order fluctuations are related to density fluctuations. And so relating it to density fluctuations, you can try and see, comparing what we would call, and this is probably too much for any of your listeners, scalar, vector, and tensor perturbations, comparing them, you can, I believe, falsify it. And I've thought a lot about it. But anyway.
Yeah, I would love to talk about that. Maybe we do. We do on this channel. We also do something called Journal Club, where I have eminent scholars come and talk about deep dives into research. Because my audience they do like to go pretty deep and stuff. And whenever I have a politician on, or somebody, I had the mayor of San Diego on, they kind of tune out. And I loved, or the mayoral candidates. I want to ask a question about whether or not there are, as a natural correlation, and perhaps you're surprisingly aberrant in the sense that most of the supporters of the multiverse are fellow traveling along with string theory, and you are a very, very prominent, kind of outspoken, critic of string theory and what it might mean.
Again, I get labeled. Well, I get labeled many things, and
we talked about this on Clubhouse once.
I know, but I'm a critic of hype, is what I'm a critic when it comes to science. So I was a critic of the hype associated with string theory. I wrote a whole book called Hiding in the Mirror, which is really about the search for extra dimensions, and it explains why string theory is very well motivated. So this as a fundamental area of physics, it's very well motivated. I happen to think probably more than loop quantum gravity, but it's the hype. It's the fact that it's this interesting idea that was claimed to be able to tell us everything, and it's told us virtually nothing, except providing an incredible amount useful mathematical tools to apply to other physical systems. Anyway.
Yeah, actually, I want to turn to that because your friend Stephen Hawking, late great Stephen Hawking, he would often, concede bets, and on the basis of a proof from, say, Juan Maldacena in 5-dimensional ADS CFT, you can recover Bekenstein-Hawking, you can get all sorts of information. But I want to ask you, I feel like he conceded that too easily. Like, how do we know that ADS CFT even exists? It's true.
No, I think look. Stephen's a wonderful man, but he's also a very astute promoter.
Yeah.
And I think he did some things he did because he realized they would get attention. And I tend to think that was the case.
Yeah.
By the way, I'm really pissed that I had what I thought should have been a famous bet with Hawking and Wilczek, which I won.
Oh wow!
And Dennis Overby was there to, but
certify
it. But he claims he's just too shy. I think he didn't want to anyway. But it was early on. It was shortly after the dark energy was discovered that I argued, and there was a great deal of all this hype about quintessence, about we'll be able to measure, that it's changing and blah blah. And I said within a decade there will be nothing that will be able to tell us that the dark energy is changing. There'll be nothing that'll be able to tell you that it is a cosmological constant, and therefore there's nothing that tells you it isn't. And there'll be no observational data. And they say, oh no, within a decade. So both Frank and Stephen were wrong, and neither of them had. Well, Stephen died, and Frank has refused to admit he made that bet. But
it's surprising because in his book, which I have somewhere here, and I talk A Beautiful Question, was written in 2014. He makes a claim that within 5 years, supersymmetry will be discovered. So I feel of Frank that, as Sir Roger Penrose once said, the quickest way to get rich is to make a bet with Stephen Hawking, because no matter what you bet, he's going to concede because of the attention, I think. And oftentimes he would have two different positions on the same.
But you don't become rich by betting with Stephen Hawking. You just get some notoriety.
Yeah, you get a subscription to Playboy or something.
Yeah, something like that. But anyway, Stephen certainly took a bet, and I never got to either. We just bet a very expensive bottle of wine, and I never got it, and it doesn't really matter. But anyway, So, but I don't think. So first of all, whether putting people in camps worries me. Yeah, I'm not a fan of the claimed progress in string theory. I have great respect for the work that's being done in many ways, which, Ed Witten is another friend of mine and someone I admire tremendously for their abilities. But string theory isn't quantum coordinate. It hasn't explained the world. But that has nothing to do with whether a multiverse is a very sensible idea. The really sensible multiverse, the well-motivated multiverse, is not the multiverse of string theory, the extra-dimensional many universes. The only one that is inescapable, it seems to me, is the one from inflation. And that multiverse, namely, there are many universes in, there need not be extra dimensions, but they're in 4 dimensions, in 3 + 1 dimensions. There are many spatially separated universes. Over time, is generally an inescapable prediction of inflation, and I find that the well-motivated multiverse. The notion that there may be many other universes in higher dimensions. I was very happy that it got one of my students Raman Sundaram tenure, but when he proposed large universes, I guess with Lisa Randall, but I've always thought it was ugly as sin.
Yeah, it's. I guess the only sense I kind of pejoratively say that they might be fellow travelers is that some claim that both are unfalsifiable. First, before I go there, I want to ask you a question. You hear this a lot as a canard, and experimentalists will say things like, "Oh, well, it's not even wrong," or theorists will say, because you can't falsify it. But I think we're overwhelmed, to use Hoyle's word or vernacular. We're kind of overwhelmed by Popper, and Popper is not Gödel. In other words, I think Gödel said something that's quantitative and not just qualitative. It is qualitative, but it's mostly quantitative. You can say what the limits of a particular field of human endeavor is or are, and but in physics, falsifiability is not the sine qua non. Nor did Popper actually say. He was a big fan of the steady state theory, as you know.
Well, yeah, okay,
or had the virtue of falsifiability.
Well, I think that there's different levels of falsifiability. The question is not, can you falsify a theory? The question is it in principle falsifiable? And those are two different things, I think.
Yeah.
So in principle, you could imagine string theory being falsifiable. I mean, you can imagine somehow doing experiments that might be able to test a prediction, if they ever made one, of the early universe. So it's not falsifiable now in the sense that, first of all, it really doesn't yet make predictions, and secondly, the scale of those at which its predictions are involved in generally are beyond the realm of our experimental ability right now. But that's a different level of something than falsifiability. And the question, the question I used to ask is inflation ever falsifiable? And I used to think the answer was no, but I don't think it's the case now.
Well, let's get into that. I mean, I have said that inflation could have been falsified if we measured the curvature to be, 0.90, which we could measure.
No, you see, you're too young. That's the problem.
Okay.
You see, you
never been a problem before, but
anyway, it's a problem now, happily it's a problem you're going to quickly get over. Anyway, or not quickly, but eventually I'll get over it. And that is that. That's why I used to say it wasn't falsifiable, because the minute before we wrote the paper on the cosmological dark energy, the conventional wisdom at that time in the early 90s of astronomers and cosmologists, and these are the non-particle cosmologists, was that the universe was open. That the curvature,
sure.
Omega wasn't one.
Density.
And that was the conventional wisdom. And in that picture, there were a million inflationary models that would produce an open universe. So the minute that the data showed that, all of the theorists would immediately develop inflationary models, which I thought were incredibly ugly, but I think many inflationary models are ugly. Which would make an open universe. And the point is, you could design an inflationary model that was what my concern was. You could design an inflationary model that would predict an open universe or a flat universe, and potentially even a closed universe. I haven't thought about the details, but that bothered me, because then I'd say, well, if we measure omega 1, and that's all, if that's the only parameter we have, which at that time we thought even that would be a stretch. Even that would be a stretch to be able to measure that. But if we could measure that, it wouldn't prove inflation happened. It would just make it plausible. But inflation wouldn't be disproved if omega wasn't 1, if there was curvature, and that used to bother me. And of course now people don't have to worry so much about that, because the dark energy has saved the day. It was one of the reasons that Mike Turner and I argued it was there, among other reasons, because it allows a flat universe, but one in which matter doesn't dominate. Yeah. Anyway,
so that would have falsified. So you're saying that would have been falsification of inflation more generically than curvature not being equal to 0?
No, neither of them would have been a falsification. None of those things could falsify inflation. What I'm saying is that looking at curvature is not a falsification of inflation, because you could design inflationary models that will allow at the end of inflation you'll have curvature.
And I wanted to just read to you a statement that I got from Kamran Vafa when he was on the show. I asked him. I said, Kamran, one of the knocks against string theory is that it doesn't have, it doesn't make predictions that are testable, and therefore cannot be falsified. And then he went into the black hole entropy, that it can be reproduced to show the degrees of freedom that back in Steinhardt
in a two-dimensional black hole,
in a two-dimensional black hole,
which we don't live in, by the way.
Exactly, right. So I mentioned that. And then he said, okay, so I said, come on, Cameron. Then he said, so for example, if you take an electron, it has a mass. And if you compute the mass of the electron in the fundamental units of physics, which is Planck mass, it's a very tiny mass in Planck mass, something on the order of 10 to the minus 23. It's a very tiny number. So you say, great, do we have any prediction that the electron mass should have been this small without knowing that there is an electron, just by knowing that there is electric charge? And by knowing that there is dark energy in the universe, you find a bound on the electron mass. From string theory, you found that it's bounded on the upper end by 10 to the minus 1 and above 10 to the minus 31 on the lower end. Okay, so Lawrence, what do you make of that? What would you give Qumran if he takes a I mean, he's basically saying the electron mass is prediction. It could have been 10 to the minus 32 of the Planck mass, but it's not. It's between 10 to the minus 31 and 10 to the minus 1. A big range, but it's a prediction. It could be wrong. It could be falsified.
I don't think it's I don't think it's worth getting hung up because the theory is just so premature that I'm not worried about its predictions because I don't think, I mean, what he's giving is just a dimensional analysis argument, which is fine. It's basically, if you have the string coupling constant of the Planck mass, ultimately, if you combine things, you're going to get some numbers. What saddens, so it doesn't bother me that string theory hasn't, I just think it's such an early, it's not a well-defined theory yet, I think. And I mean, it's got a lot of great ideas and maybe it'll relate to the real universe at some point. It's as I like to say, and this is a joke of Frank's, it's promising, but it's been promising for a long time. But
like nuclear fusion.
But what really disappointed me the most, to tell you the truth, is the one thing, if string theory had predicted a cosmological constant, it would have been great. But in fact, not only did it not predict a cosmological constant, but generally it has a hard time even existing with one, and without a negative one anyway. And so that's the one. I'm personally convinced that we won't understand the energy of empty space until we have a quantum theory of gravity. I suspect they're intimately involved with each other, and so. The one thing that I would want a purported theory of quantum gravity to tell me something about would be the cosmological constant. Mm-hmm. And as far as I can tell, neither string theory nor, for that matter, loop quantum gravity have had much of anything to say about them, and certainly didn't predict them. Generally, find that generally string theory would suggest that what we're seeing now is a temporary aberration of what will ultimately be a negative cosmological constant. Anyway.
When I see a proliferation of anti-string theory, not your work necessarily, books by Peter Woit, Sabine Hassenfelder.
Yeah. But let me make it clear. I don't think I've ever. Yeah, my book Hiding in the Mirror is anything. If anything, it's a. I wrote that book to praise string theory, not to bury it.
Right. So, but you do hear these cries that string theory is effectively sucking the oxygen out of physics departments, and that I don't know.
It used to be more. I think it was, and it's certainly. There's no doubt it was in the 1990s. Mm-hmm. It was, but I think you know what happens? It's the wonderful thing about rats and a sinking ship is that the minute there was the possibility of new experimental data, either at the Large Hadron Collider or in the universe, what you saw, I mean, there's a certain subgroup that were lost forever to physics. And I used to see them when I was at Caltech. I gave a colloquium once at Caltech, and it was when Ed Witten was being courted there. And as I say, he was a friend of mine, and we had lunch. And then right before the colloquium, I was with another friend of mine, Mark Wise, and we were walking towards the building, and all of the young string theorists were leaving. And it was right before my colloquium, and Mark said they never come to physics colloquium because for them physics is, it's just something way below the Planck scale, and it's not of interest. It's like botany, and so for them, everything that was relevant for what you would normally call physics was not interesting. There was a subclass of people who felt that way, that if it was below the Planck scale, it really wasn't interesting. But what happened is for many young people who were not lost. The minute there was experimental evidence or of anything interesting, everyone started to think about that. So you had string theorists start thinking about cosmology or the Higgs particle or other things. And but it did for a while skew seriously. And as chair of a physics department at that time, I was very aware of it. It seriously skewed the appointment of young faculty and the ability of young people to get jobs in physics who weren't string theorists. And that was sad. That was unfortunate. Again, you're lucky that you weren't in that generation.
That's right. But again, then I have people like Michio Kaku coming on and saying no, because I asked him, I was like, where in string theory does one find the muon G minus 2 anomaly? Or where do I find the Large Hadron Collider beauty results, these anomalies and so forth? Where do I find Hubble tension? And he says, it's all there. And I say, what do you mean? He says, you just have to tell me the vacuum state. And I say, well, why is it my job as an experimentalist to tell you what the vacuum state is of your theory? And yet, on the same token, the swampland, et cetera, it seems hopeless, Lawrence. And I'm wondering, why is it that you get so much attention from people like, Kaku with the God equation and Stephen Hawking even talking about M theory as if it's proven, as if all physicists accept it.
Because it sounds profound and everyone wants the next best thing. Then, after Einstein. And Stephen, I think, to his credit, he may have talked about those things, but his work was generally, calculational and involved things that you might be able to, at least in principle, predict. But relevant. Obviously, black hole evaporation is profoundly important. I frankly do have a problem with Michio Kaku, and he knows it. I've done it many years ago. I did this radio program. We've been on programs together, but I think he inappropriately misleads people about string theory, and I don't. I don't look. Whenever I'm talking about science, I'm sure I lead to misconceptions to people, but I don't knowingly lead to misconceptions. I try not to knowingly swindle people. And I'm not saying he's a swindler, but I believe that people, that knowingly statements are made that I think are not justified. And it is true. But he's absolutely right in principle. If string theory were a theory of space and time, then obviously, in some level, and a complete theory that from which all the forces of nature were derivable, then obviously it's in there. Because if it really were a theory of all the forces of nature, then all the things we measure must be a part of that. So it's a tautology almost. So of course, in principle, it's there, but we don't. But first of all, we don't know how to do it. But more importantly than that, we don't know if it is. We don't know if this incredibly fascinating area of mathematical physics is a fundamental description of our universe, or whether it's a mathematical tool that allows us to understand many other areas in physics. And that's the most important question. I don't really care about, at this point, whether it makes predictions that you could test, because I think we're way away from that. The question we really have to address is that there's no evidence yet that it is a theory that string theory describes our universe.
Right.
Okay.
So I guess we're going to go off of Kaku in a second, but I did ask him one thing. I said, if you were the president of the National Science Foundation, you have a portfolio and you have to balance your portfolio. How would you say the portfolio should be balanced, given that there is, tremendous overinvestment to some people's minds into string theory, and dramatic underinvestment in new models like Stephen Wolfram's model? Eric Weinstein has the geometric unity proposal, and of course twistor theory, and so forth. So how do you balance the proposal? Now I made you, director of the NSF. What do you do, Lawrence? It's fine to say "let 1,000 flowers bloom," as the individual once said. But how do you balance a portfolio?
What you do is peer review. I think and you have to look. First of all, by the way, it doesn't really matter because it's in the costs of string theory, by the way, compared to the other things you said, string theory is on a wholly different level compared to the other ideas you talked about. It's not really fair to put string theory at the level of those other left field things you talked about. The string theory is really well motivated from a fundamental direction, but they're the Xeroxing costs associated with the Large Hadron Collider. They're just in the noise. You could, in fact, by the way, that's the way it's normally done. When I was at Harvard, the theory group, the only reason the theory group was funded was because they were combined with the experimental particle group. So that basically they were getting the breadcrumbs that was being thrown out by that because experiments are so expensive. Theory itself is pretty cheap, but nevertheless, what you have to do at some level is broadly have groups within physics assess what are more likely or less likely. And I do think it's really important to fund a variety of options. But as the editor and the publisher of the New York Times once said, and I've quoted, actually he wasn't the first one to say this, I've since learned, but he used to say, as Sulzberger once said, I like to keep an open mind, but not so open that my brains fall out. Right. Ultimately, you it's reasonable to fund things, but you've got to, but they have to fall within some range of that the community views as realistic, well motivated, well defined, and I don't think so. When it comes to particle physics, particle theory, there was a time when I think string theory is probably getting the lion's share of money, and people who weren't doing string theory complained. But to be fair, it was so attractive that you generally had the most capable young theorists working on it. Mm-hmm. And so it was attractive enough to drive. I mean, these people were voting with their feet. So look, it's always a hard thing. It's like asking. First of all, it's not a zero-sum game, right? It's like when people say, should we fund the Large Hadron Collider or should we fund erasing poverty? And the point is that it's not one or the other, okay? And if it were, we'd be in a really sad situation. It's not one. And so I think that what you can do is you can, if there's a lot of interesting intellectual work going, you might expand the pot. Or if there isn't, you might contract it. And frankly, there have been times over the last 25 years when I've often thought we probably are funding particle theory too much because there wasn't much of interest going on in that area.
And it's an attractive nuisance in that there aren't, there's as few spots to become faculty in high energy in any academic. We had a search last year before COVID. We had 400 applicants for one position.
Well, listen, I remember when the Superconducting Super Collider was canceled. That was the year before I became chairman at Case, and I moved there because I was given 13 new faculty slots to build a department, and I'm very proud of what it did there. But within 3 weeks, I got 200 applications from experimentalists from the Superconducting Super Collider, all of whom were really good experimentalists, many of whom would stake their careers on this, had left their jobs at tenured jobs at other institutions, and now had no options. And I couldn't hire any of them because the point was, what are they going to work on? Right. I mean, it was different. I was trying to grow a department, and I had to hire people who were going to have an impact on an emerging field because they had to be very strategic there. If I were Harvard, I could always hire an extra experimentalist in that regard because I didn't need it to. But there are so few people, as you say, who get jobs in universities, and I have concerns about how that process goes. The main thing ultimately, and this was my guide when I was a chair, and so I didn't care if someone was a string theorist or not. Whenever I've been on a search committee, my feeling is you always hire the best person, namely the most capable intellect, who may be doing something now, but the point is physics evolves. So even if what they're working on now is interesting, in 3 years it may not be. So you hire someone who you think will be able to move with the field and continue to be a force. And so I think that's ultimately because I believe in meritocracy. I think academia should be a meritocracy. That should be the only requirement that comes in, ultimately that comes down to things. And then it doesn't really matter the field that people are working in. It's their quality of their intellect in a way that matters more than anything else.
So we'll get to meritocracy and science and elsewhere. I just want to remind people I'm talking with Dr. Lawrence Krauss, author of many books, including his most recent book, which we have yet to get to, The Physics of Climate Change, A Universe from Nothing, The Greatest Story Ever Told, Atom, all these physics of Star Trek. He is the proprietor of the Origins podcast, which is a must listen to. I've poached many of his guests. He's also a director, founder of the Origins Project Foundation, which I'll put links to in the show notes. But the last thing I want to say, just before we move from really the hard science, the big picture questions, I've started to think a lot, Lawrence, about, how I can rekindle a little bit of that, a milli or a nano Galileo, and recreate what he called the assayer, il saggiatore. And that was to, like, what does an assayer do? An assayer doesn't own any gold, but he has a rock, and he takes what is purported to be gold and he rubs it on the rock. And in so doing, he provides value of potentially untold wealth, or he crushes the dreams of people that thought that they got this gold from their, great uncle or whatever. So that was what he did. That's what an assayer does. I'm wondering, are we missing things now? People tell me to test my theory. Stephen Wolfram is on my podcast. He's talking about bronchial space and this bronchial, not like your chest, but branching space, and sort of how you could test it. And it would require, it could actually be falsified, but it requires, advanced LISA or what. And I was thinking, and I said to him, I said, what if you tell me you need this future collider? Okay, there's no target, there's nothing natural, but bigger is always better. What if I said to you, like 10 years ago, I'm going to give you something that can crash two atoms, two nuclei together, and they each have 10 to the 58th neutrons, and I'm going to crash them together at half the speed of light. Would that test your theory of everything? In other words, we have phenomenal, energy scales accessible to us. Why are we missing something? Newton, as you talk about in the greatest story ever told, you talk about how he was right about light. He proved that light going through two prisms was not diminished any more than going through one prism, right? And I was thinking he proved the color theory of light in a lot of ways. And that is a quantum, at some level, it would be something that Feynman would have recommended. In other words, what low energy phenomena are we perhaps overlooking because we always have this bigger, better, greater, farther, faster, higher energy frontier to pursue?
Well, look, you're not alone. And I don't think a lot of people, and in particular myself, and I mentioned the work over the years that Frank Wilczek and I, when we worked together, have been looking at ways to use. There are two extremes of physics. There's the energy frontier, but there's also the sensitivity frontier. And in the atomic physics domain, sensitivities are achievable now with not, you could call them tabletop. They're not really tabletop, but they're not LHC scale experiments. Most of them occupy a single room or two. And you can achieve sensitivities looking for things at 1 part in 10 to the 18th, sometimes 10 to the 20th. And so the question, of course, is there's two ways to detect new physics, new fundamental physics. By fundamental, I mean associated with the fundamental forces of nature. Not, I don't want to have this big argument about whether what's fundamental. But
no, I agree. Yeah.
But one is by probing directly those scales, and because of quantum mechanics, to probe, physicists don't build bigger machines because they want to spend money. You need quantum mechanics says the more energy you have, the smaller the regime you can resolve with your microscope. It's just that simple. If you want to think of it, the smaller the wavelength of your probe, and the wavelength goes inversely with energy, the more you can probe matter on smaller scales. So we have to build bigger accelerators to detect things on smaller scales. But the other way that phenomena at small scales can be manifested is by very, very weak effects at macroscopic scales. And so a very interesting, and it's an area that's growing all the time, is to look at ways that we might use ultrasensitive experiments to probe for very rare processes or very weak effects that might be new. And so, that's a vibrant area of physics, and one which I've run several meetings about, one which I've worked on. One of the last papers I wrote was on exactly using lasers, atomic clocks, to try and probe for something called axions, because I'm fascinated. I actually came up with that idea. What I was giving, as you know, because I came to UCSD to give this math lecture. For many years I gave more public lectures at a number of meetings, and this one was a metrology meeting in France, and they wanted a cultural talk on cosmology, if you wish. And so I was there, and then after my big talk, which opened the meeting, I listened to the talks, and of course, a lot of it was highly technical. But I told myself, I should try and make the most of this, and it was there when I began to appreciate the incredible power of metrology and atomic clocks and to be able to probe things. So that I think, and the point is, you never know if you're missing something, right? All you can do is try and this is what I was going to say to you about the National Science Foundation. And I know the director of the National Science Foundation. He worked with me at my old university. Ultimately, what people don't realize, a theory, we talk all about these theories, but physics is an empirical science. All of science is empirical. And what should drive the science is experiments, not theory. And generally, that's what does happen. So that's where the money should generally go. The amount of money that should go into theory should always be a small factor compared to the amount of money that goes to experiment. And so my feeling has always been that you should do the experiments you can do. And whenever you have come up with a new technique, it's worth exploring it because you never know where it's going to lead. And people always say, what's the next big thing? And I always say the same thing. If I knew, I'd be doing it, right? Okay. So we obviously are missing things because that's why experiments surprise us, and that's why I as often say, I'm surprised every day, and some days I'm surprised that I'm not surprised when I hear new results. So we keep opening up new windows on the universe, and that will guide our understanding of the universe. Not what theorists do. Theorists provide, a framework, and there are clear counterexamples where theory has changed our worldview. Galileo was an example, and obviously Einstein was another. But generally, it works the other way around, and people don't realize that.
And one thing I've been curious about is why are there so many popular science popularizations, popularizers, however you want to say it, dating back to Newton and to Einstein. And, I actually have one doll. So I've got Carl Sagan. Here's Carl Sagan. Here's Galileo. You saw him.
I'm not sure Newton was a popularizer, by the way. Newton was detested the public. But anyway. Anyway.
But I have had one. I do have one finger puppet. And here's Einstein over here.
I think I have that same set. Okay, go on. Yeah.
But then I have one that's been a guest on my podcast, and that's Noam.
Oh, okay, there we go. That's great.
So maybe we'll get a Krauss doll. But I want to ask you, why
as long as you don't start sticking needles in it, I'm fine.
Okay. Well, they go on my thumbs.
Yeah. Okay.
Anyway,
I don't want to even go there, but go on. Yeah,
that's right. Yeah, exactly. The question I have is why is there such a surfeit of popularizers of theoretical physics? Brian Greene, Lisa Randall, Janna Levin, Katie Free. There's so many, and there's almost nobody who's an experimentalist like me. And
because theory is sexy. Let's face it, theory is sexier. It really is because you can. Hype? Mm-hmm. It's the hype, no, but it's also the tradition. I mean, of the lone scientist sitting in the room late at night thinking about the universe, and it's so easy to make hypotheses about grand hypotheses. Where if you're an experimentalist, you actually have to do something, and the devil, if you're an experimentalist, is in the details, as you well know.
Yeah,
with the experiments you've worked on, and that's not what tends to get press, because the press generally, just reproduce the press releases of the people writing books, and that doesn't get to capture people's imaginations. And it's sad because I actually have tried in my books very carefully to point out the experimental basis of things, because it really is the heart of science. But I think it's just that it's the reason I became a theorist. It's sexier. Mm-hmm. I was an experimentalist. I worked when I was an undergraduate, I worked in summers in projects of high energy projects, and I'd spend, and then during the year I had part-time jobs, and I'd spend 8 months trying to fix what was then what's called a spark chamber, and the things that would occupy me for a long time that would take forever to do almost nothing, and it certainly turned me off. But but I admire tremendously now that I'm older. I certainly almost feel wistful that I because I find, I've been now involved. For the last 30 years, I've proposed experiments, many of which are being done. And I'm wistful. And for the first time, actually part of an experimental collaboration. But I'm almost wistful that I'm not experimentalist, because the difference between a theorist and an experimentalist is that an experimentalist actually does something. Has something to show for what they've done. Whereas a theorist has just has ideas, and there's no priority really on ideas, and though we always try and have that, and it's just my respect for experiment has increased exponentially from the time I graduated. In fact, when I was, to be fair, when I was an undergraduate, I did 2 degrees, one in mathematics and one in physics. The reason I did that at my university was it got me out of an experimental class. Okay. I mean, it wasn't the only reason. It was, to me, it seemed the most challenging option at the university I was at. And so I decided to do it. But one of the many virtues of it was that I opted out of the experimental class, and sadly now I wish, not that I wish I'd done it, but I think people don't appreciate, because we all talk about it. I mean, you and I have been talking about that because these ideas are fascinating, and there's something that people can relate to without knowing details of statistics or diodes, or I mean, and so even though there's incredible intellectual baggage that really is required to get any kind of adequate understanding of theory, you can build it up in a way that. But I think to really understand that the guts of an experiment, it requires a lot more intellectual baggage that very few people are willing to carry to get there.
My late father used to say that to be an experimentalist, you actually have to know the theory at least as well as a beginning grad student or something. You don't have to come up with new theories. That's not a requirement that I put on my experimental graduate students, but you should at least be conversant in it, unless you just want to be a technician. There's nothing wrong with technicians. We need them. But if you're not going to think about the big picture, and I wonder, Lawrence, is that, I find, I make a joke. People are like, why are you doing this podcast? Is it just to make the tons of money that YouTube sends us every month for our creator? No, and I say, actually, why I'm doing it is because on my day job, which is to, co-construct the Simons Ray, the Simons Observatory, it is usually involving people I have to talk to. In other words, it's people, and it's very long term. I mean, we won't complete the observatory, the array. It takes a decade, to complete these experiments. They go on for decades. But a podcast is kind of instant gratification. I can talk to people I want to talk to, not the plumber that's telling me that there's this leak in this Freon thing at 17,000 feet and I might have to get on a plane. But instead, it's people I want to talk to, and not that I don't like those people. It's just it's a drain. There's a lot of experimental physics is sitting around bored and then terrified when something doesn't work. But I wonder, is that partially why you started your podcast? Is that to get the instant gratification of talking to some of the world's leading intellectual lights?
Well, look, podcasts I've been doing, well, first of all, I'm fortunate because my field allows me instant gratification, right? I mean, there are 2 types of theorists. There's some theorists who work on one thing for 30 years, and I don't want to put that down anyway because it's very important. But I've worked in everything from geophysics to black hole physics to some mathematical physics and so for me, I love, I get instant gratification by learning a new thing and working on it, and then I go away, which actually I've talked to Frank about this. Strategically is not so good, because when you write the first paper on a subject, by the end, in 20 years, it's never referenced anymore, because everyone's always, unless you continue to write papers on, but that doesn't matter. And so I already get a lot of, as a theorist, I can get quick gratification that way. Mm-hmm. But it's more, no, it's deeper in the sense that, first of all, I've been doing this for a long time. Even before I created the Origins project at the last university, even at Case, I'd built an effort to try and bring different people from different areas together, because I find that symbiotic relationship between knowledge at all levels interesting. But then I expanded it. I mean, then it was still mostly what you would call academics. But then what for me was the driving factor is that I believe science is part of our culture. Not that I believe it. Science is part of our culture. It should be more integrated in our culture. And that means it's cultural. And therefore, for me, it's a matter of bringing people from all aspects of culture together. And I'm fortunate, and you've been fortunate by poaching, but I'm fortunate that for some reason or other, I realized when I was doing the Origins thing that I had a very broad Rolodex, if you want to call it that, of people of significance in Hollywood, in different areas of academics, and in even politics and journalism. It just happened over time because I've been involved in a long time. There wasn't any planning. And so I thought we discovered, I ran large panels, but then we discovered that one-on-one dialogues were fascinating. And I did one with early on with Chomsky, but Alan Alda, and I did one with um, Johnny Depp and others, and that people are fascinated by being a fly in the wall. And as one of my editors once said, people want to go to the horse's mouth, and so what they want to hear are the people that they want to hear from. And so my feeling was, if I could get them together, but not just some superficial thing, to create a dialogue that would be different, that would be the kind of thing people couldn't hear about everything that person was thinking, and put in perspective, and which is why I tried to prepare so much for all of the podcasts. That would be something that people might like, and it would also, frankly, archivally serve a very useful purpose, because in the future people will have that to work from. But you're right in one sense, and this is the sense that I think all people don't realize why people do science. Most things I do because I want it, because they make me happy, right? And most scientists aren't scientists because they want to save the world, even if they're saving the world. It's because it makes them happy. They like what they're doing, and you're absolutely right. The podcast gave me an excuse to go around the world and have in-depth dialogues with people who I may have had as friends generally, but in-depth dialogues that I wouldn't have had otherwise. And so really, in some sense, of course, it's for me, even though I think it provides a more useful purpose.
Yeah. So some of the 8 other Nobel Prize winning guests that weren't influenced by you that I've had on my show, for the same reason, I've written a new book that's coming out in September, just distilling those conversations into chunks of actionable information. It's called Think Like a Nobel Prize Winner, because I felt like it would be a shame if, A, as you said, there wasn't archived.
Mm-hmm.
B, the transcripts are kind of, meandering, and it's hard to keep, as you know, as a host and a guest. And when I'm meandering just now, you're getting an in-depth class on that. But I wanted to distill it into chunks of actionable information, and some of the things were really inspired by things that surprised me from the guests. In other words, I talked to Barry Barish, and I said, Barry, one of my audience members asked me, do you ever have the imposter syndrome ever in your past life? And he said, what are you talking about, my past life? I feel it now more than ever.
Yeah, sure.
And a vignette that you and David Gross spoke about last week on your podcast, when they win their Nobel Prizes, they have to go up and sign this ledger that says, yes, I received my medallion. Barry left us here in the couch over there when he was visiting. But you have to sign this ledger, and it's impossible not to be curious about who came before you. And he looks through it. He sees Feynman. Okay, Miriam Mayer, we'll get to in a second. And then he gets to this guy. He gets to Albert. And he said, I've never felt more dramatically inadequacy, uselessness, and imposter syndrome.
Well,
and I said, yeah, go ahead.
Well, no, why don't you finish, and then I'll jump in.
Well, I said, you know what? I did some research, Barry, and that's actually what inspired me to actually take his words and put it into a book along with the 8 other laureates, including Frank, Shelley, and many others. But I said, you know what, Barry? You know who else had imposter syndrome? Einstein. He thought Newton was the greatest intellect, the greatest contributor, Lawrence, to Western culture. Einstein called Newton. And you know who Newton, of course, worshipped more than anybody, and before whom felt the imposter syndrome, Lawrence? Do you know who that was? What scientist that was?
Was it Galileo? I don't know.
No, Jesus Christ.
Yeah, I was going to say Jesus Christ. Yeah, I was going to say, because he didn't. I should have known the answer, because there's no real human that Newton would have felt subservient to in any way.
I want to get that. You were going to say something when I meandered on.
Look, it's easy to. How can I say this in a way that sounds right? If you ever achieve a level of fame at some level of celebrity, and for one reason or another, because of whatever I've done at some level, I have. You realize that and this is what I think a lot of Nobel laureates have to come to grips with, because until they win the Nobel Prize, in their own community, they're well known, but they're not well known outside their community. And then frankly, they're not that well known outside their community afterwards. There's a little blip, but you have to not believe the press clippings, because every press clipping, there's not. I mean, when I go give a talk, or when I see anyone else, they're always presented as, when I see a blurb in the book, as the next Einstein, the next blah 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 blah, and it is really easy when that's happening, because you're not, to get that imposter syndrome. Hey, I'm being described as something I know I'm not, and maybe I'm just a complete fraud anyway. And I mean, I think anyone, I certainly have felt that many times, and people would say rightly, but I think it's, if you don't, probably then you suffer from the Dunning-Kruger syndrome, because I mean, it's part of the problem. I mean, how can I say this again to you? Losing the Nobel Prize. There's this fixation on Nobel Prizes in the first book and the second book that is unfortunate in a way, because first of all, I've known almost every Nobel Prize winner in physics over my time anyway, and in many other fields as well. I probably know 50 Nobel Prize winners, maybe more. But it's just a prize, and suddenly it instills this stuff, and it's for work. And the person, suddenly the person who won the Nobel Prize is seen as is elevated to some level when it's the work, and the person may or may not be worthy of being elevated to that level. They did some work. It may have been an accident. It may have been other things.
Right. Look at Fritz Haber. Look at
there's lots of whatever. Yeah. So we as a society, the public tends to label Nobel laureates as if there's something special.
I think it's a form of religion. It's a form of almost secular worship.
But in general, it's really recognizing work. And that was one thing. Speaking of philosophy, because I used to read a lot of philosophy and ancient history when I was younger, and I almost took a Rhodes Scholarship at Oxford. I was going to do physics and philosophy. Thankfully, I didn't do that. The ancient Greeks and Romans were really quite different. They separated the work from the artist. And so they revered the work, but they didn't revere the artist. They would basically say, they thought it was a divine inspiration, and that this person had more or less had just happened to be the vessel of the gods. But it was like, big deal. And we've gone the opposite direction in some sense. And it's a cult of celebrity we live in. And so because of that, I would suspect that many people, after getting great adulation and recognition, most people who are at all self-critical wonder, ask themselves, or quickly realize they shouldn't believe their press clippings.
Yeah. Yeah, except for Frank. When I talked to Frank, I said, "Did you ever have the imposter syndrome?" He said, "No." It was basically the opposite. And
well, Frank, I've known him for 40 years. Mm-hmm.
Yeah, he had to wait for 30-something years until he actually received it, and I thought that would be excruciating. But I mean,
it was excruciating. Let me tell you, I don't know what Frank said, but I've lived with it. Okay, every year. I'm sorry, Frank. Yeah, every year, Frank and I would have this call because we were extremely close friends, and he, I think, wouldn't talk to many people about it. It's hard if you think it's hard, and what you shouldn't. And the point is, you shouldn't fixate on it, but it becomes harder and harder. I was very, very happy. Not only because the work deserved it, and I actually was a nominator for the Nobel Prize, and that was one of the things I had nominated. But in fact, everyone I ever nominated for the Nobel Prize, by the way, won one. But anyway, not that. But it may have taken 10 years for that to happen. But it relieved a kind of tension that for some people it could really hurt them as scientists and their personalities.
No, that's what I wanted to dispel. When my first book, was written from the perspective of someone who was told when he was hired that he was hired because he thought the chairman, whose father, Nikolai Basov, had won the 1964 Nobel Prize for the laser. He said, "We hired you, and we're only going to give you tenure if we think you're on a short track to a Nobel Prize." And even after Bicep 2, people say things like this. And I just think it's a charade in a sense, because, again, we should venerate the people. I actually think that the people are more impressive than the institution. A lot of the prestige of the Nobel Prize has come because of the people that have been awarded it. And I think it's interesting when you think about how society is sort of venerating this. And by the way, you mentioned the Dunning-Kruger effect. I just want to point out that I am, perhaps the world's greatest expert in the Dunning-Kruger effect because I studied it for a little bit. I want to turn now to meritocracy, which will.
Well, but let me just say one thing. I think. Yeah. I don't want to focus on Nobel Prize too much, but I've been strongly involved in following it and as I say, nominating and then at the Nobel Prize ceremonies.
Mhm.
And one of the things that amazes me, no, it doesn't amaze me. It's the reason there's a profusion of prizes. And I remember when Fred Kavli talked to me early on and was at the Nobel ceremonies with me once when he was trying to emulate it with his Kavli prizes. I said, Fred, don't waste your money. It's never going to be a Nobel Prize. But the difference is, and it's a waste of time, but these people are willing to do it, that they spend a full year. They spend a year, the day the Nobel Prize announced, they meet the next day starting for the next year. And what's amazing is they could have blown it so many times and generally have. Now, there are a million people who deserve the Nobel Prize that didn't get it, but there aren't that many people who got it who didn't deserve it. There are some. And by that, I mean, not as people, but I meant but the work. And they do an incredible job of vetting it, which is why all these other prizes are so subjective and peripheral. They just sort of throw names in a hat, and that's why one of the many reasons I just think there are far too many prizes in science. But I will say that they've generally done a good job, and it is surprising on the whole, given that the work is what wins the prize, not the person, that remarkably, but not completely, but remarkably, a large number of people who won the Nobel Prize are also really good scientists. Not everyone.
Yeah, that's true.
But it's amazing that correlation is kind of good, and I do think that adds at least that history at least adds something to the validity.
One of the ways
But my friend Martin Rees is totally opposed to the Nobel Prize.
I know he hates it. Yeah,
well, he's right now that this notion of three people is just kind of silly in science.
Well, yeah, all the laureates rail against that I've interviewed.
Well, after they win, it's easy. It's easy. Anyway,
Anyway. Like, I don't see you like turning it down. All the Nobel Prizes except for chemistry and physics have been rejected by at least one.
Yeah, no, I wouldn't. I'd take the Templeton Prize if they gave it to me. I'd take the money, and I badmouth the prize, but I'd take the money.
That's what I say. I say, if you want to find out if Keating's a hypocrite, just get me the Nobel Prize and see if I turn it down.
Yeah.
But turning now to that topic and also your celebrity, your prolific following Twitter, elsewhere, you get 500,000 or so followers, etc. There's a line in Animal Farm where the pig talks to Benjamin the donkey. And the pig says, Ben, you got this long tail. It's so beautiful. You're so lucky. And Benjamin the donkey says, yeah, the good Lord gave me a tail to swat away the flies. But to be honest, I'd rather not have the flies and not need the tail. Right? Do you wish you had a pig-like tail? or do you wish you didn't need a tail that you have? Or the kind of fame, attention, celebrity, scrutiny, criticism.
It's first of all, it happens, right? So it doesn't seem to me that, there are good things and there are bad things. And I've gotten to do many things that I would never have been able to do otherwise. Tremendous, and including many of the people I know that I would never know otherwise. So it's from a personal perspective, it's been wonderful. Especially in modern times, if you have any celebrity, it's also awful. I would like to think that I wasn't driven by that, but I am also realistic enough to know that I probably, at some level, probably craved some attention. We all do, but so I know. But I think that I like to think I did what I've done because I think it's worth doing, and I've been, on the whole, I would say I've been pleased by the opportunities that I've had. And moreover, it's not a choice. I guess that's the bottom line. I did what I've done not because I chose to do it. I didn't have a choice. I just like I bounced around in physics, I'm interested in a lot of different things. And I'm not, from a personal perspective, I guess a traditional academic in that sense. Academia itself has never been enough to lure my sole interests. And so, in fact, one of the reasons when I told about physics and philosophy, one of the reasons I hesitated about doing a PhD in physics was because I'm very political and I'm very interested in people, and the kind of physics I was interested in had nothing to do with people.
Mm-hmm.
And it turned out but there was no plan. It turned out I was able to mesh those two things, my interest in science, my interest in people, because of the popularizations I got involved in. But it wasn't, there's some people I know who are very systematic in this regard. My friend Neil deGrasse Tyson is incredibly systematic his whole life. He knew what he wanted, what he wanted to achieve and what he had to do to achieve it. And in my case, I just basically, it's an accident. But I do know that if I didn't really have a choice. I think if I hadn't been writing and speaking, I probably wouldn't have been able to focus on physics. And if I hadn't been able to do physics well enough to be able to achieve some level of whatever the word is, credibility, I guess, then I wouldn't have had the opportunity to do the writing and speaking. So I think it wasn't a choice anyway.
Yeah. And there are a lot of people that, whenever I want to damn one of my guests with faint praise, he's got some new theory about something, I'll say, they know the history of physics really well. Like, because you can get away with a lot if you just like spew, kind of historical platitudes and then throw in an equation or two. But I'm going
to interrupt you again. One of the reasons I love writing books, and I've written a lot, and I guess I'm on my 12th now, but is
Show me your hands. Show me your hands, Lawrence. What are you writing now? I think you're writing something right now.
I am, but I can't show you my hands because it's like poker. But one of the things I like about it is that I learn a tremendous amount, but I also learn history because you can spout. In fact, just this morning when I was working on a new book, actually, I read something I wrote and I said, is that really how it happened? And then I started to go back and discovered what I've always said about it is totally wrong. And so when you put it on paper, at least when I do, I don't know about other people, it has a level of seriousness which it doesn't have when you're just lecturing or talking. And so I've been able to learn a tremendous amount of history just by writing about it, because then if you write about it, it's like teaching. I mean, if you write about it, then you have to learn it.
Yeah, but I think the contrast with what you do and what I try to do is, there's different types of content creators, and there are those that document what other people have done. Then there are people that document what they themselves have done. I think the latter is always more interesting to say, like even to expose your own warts, failures, and flaws and your thinking process and the wrong turns, because that's the problem, I think, and I'm going to get off the Nobel Prize, I promise, but that we present, physics as done by Nobel Prize. I mean, my freshman lab classes are, 4 of them are, Nobel Prize winning experiment. I used to do at Case Western, I would do the Michelson-Morley experiment. And one day I did the
By the way, I'm always pleased to say I had the chair that Michelson had when I was.
Oh, wow.
Anyway,
that's great. Sean Carroll's got the desk that Feynman had. For other guests on the book. But I do say, it kind of distorts the way that history is done. It's not written only it distorts the physics process. It doesn't distort history. It's not lying. It's just, that's not the way science proceeds. It proceeds via millions of wrong turns. And then finally there's a path that works the right way. But I want to stick on.
By the way, Feynman probably didn't work at his desk, so it's okay.
That's right. The strip club around the corner.
Well, anywhere else but his desk, so it doesn't really matter. Anyway, when was that going?
Okay. I want to turn now to meta-scientific questions. And in particular...
And one of my favorite books, by the way, is my book on Feynman.
Quantum Man. Yeah. I'm going to put a link to it.
I worked very hard on that book. And
actually, you know what? If you're a member of Audible, you can download that book for free. So that is a free book that you can get if you're an Audible member. So I can listen to it again. And I have copies
good.
of it.
I can download it and listen to it.
When you were here, you signed many copies of it for my undergraduate who got the highest score in my cosmology class. So I gave away one of those, and I kept one with your signature on it in the corner over here in Jeffrey Burbidge's old office.
That's nice. It was a labor of love, and it was a
and you
joy
met him. There's a famous picture of him with you chatting. But you had long sideburns. You had mutton chops, I think, at the time.
Well, I had long hair, very long hair. I was young. Anyway.
So the next kind of pivot, if you have time, I know, I can keep talking all day, as you know. I'm a New Yorker.
Yeah.
So, but I want to ask you certainly questions from my audience. I've got about 13 questions from my audience. But before I go there, I want to talk about a term that I believe you coined called the ideological corruption of science.
Uh-huh.
And I want to be kind of steel man against that. So I'm at UC San Diego,
Uh-huh.
which is the home of the late great Maria Gephardt Mayer,
Uh-huh.
who when she won the Nobel Prize in 1963,
Mm-hmm.
the San Diego Evening Tribune ran the following headline: "San Diego mother wins Nobel Prize." And that's really funny until we realized that Andrew Lang's widow, ex-wife, Frances Arnold, when she won the 2018 Nobel Prize, the initial headline on JPL, I tweeted out and she responded to it last week, was mother of JPL flight tech wins Nobel Prize in chemistry. She was laughing about it. She liked it because it gave credit to her son. Anyway, I'm here at UCSD. We only have our physics department named after Maria Gephardt Mayer because Johns Hopkins was too sexist to give it to her, and they would only give a position to her husband. And so we said we give a position to you, Maria, and your husband, and he kind of came along as a spousal hire,
Sure, which happens a lot nowadays. Mm-hmm.
And back in the day, of course, Einstein was forbidden from winning a Nobel Prize. When I hear folks like Heather McDonald say on this podcast, what do you think that physics is systemically racist? There are no Nobel Prize winners because systemic racism exists in the Nobel Academy. I said, Heather, do you think physics is time, translation, invariant? In other words, do you think the greatest minds of human history would have been the greatest minds in any other generation? And she said, yeah. And I said, well, 100 years ago, Einstein, there was meetings by folks like the Aryan chief of physics, Bert Leonard, and others that said, no way in hell is Einstein getting a Nobel Prize, and only is getting it if he does something related to non-Jewish physics. So I want to ask you, Lawrence, what makes you think that nowadays, not just the Nobel Prize, but hiring, faculty decisions, tenure decisions, postdocs, graduate students, all the way up the gated the kind of academic Hunger Games that I call it, what makes you think that we're so meritocratic and that that's actually the best way to go about things?
Well, because again, I'm an empiricist, and Einstein, you know who Einstein was, right? You actually talk about him. You have a puppet and all the rest. In spite of the fact that he was a Jewish physicist who had problems at the time, and the reason was his work. Ultimately, he and his work overcame it because that's the way science works. Because the science is a meritocracy. The problem I have is that, of course, there are always biases at any given time, and you're absolutely right. There's a time the world is not time translation invariant, but I find it interesting because I think in a piece, I don't know if I wrote it. I guess that I probably, in that piece for the Wall Street Journal I wrote, I don't think I talked about it there. I think I may have talked about it in a companion piece for Quillette because I was allowed to have longer space. But when people talk about systemic racism, first of all, I've been a chair of a physics department. I've been in physics departments and involved in hiring for a long enough time to know that that if anything, it's quite the opposite. I mean, the craziness of even the defining the way it was. I talk about in one of my articles that when I was chair of physics, I tried to hire a really good black physicist who was someone I know and respect, who's a condensed matter physicist from University of Illinois at Urbana, who was tenured, and he wanted to come. His wife was going to come to case actually and so he was going to be a trailing spouse. And I desperately tried to hire him, and was not able to because he wasn't a minority. He wasn't. Mm-hmm. He was from Bahamas, I think. He was not African American, and so that arbitrary definition was just ridiculous. But the example I used about this problem of claiming systemic racism and how to resolve it was the anti-Semitism of the scientific community, which not only Einstein dealt with, but Feynman had to deal with. And I use the example of Feynman. Feynman was applied to graduate school at Princeton and nearly didn't get in because basically the head of the physics department said, how Jewish is he?
Yeah, exactly.
And talked to the chairman of the physics department at MIT, who basically said he's not very Jewish. And in looks or in whatever. And so they allowed him in. Okay. But what happened then? Okay. They didn't have to do a quota for Jews. what happened is Feynman became one of the best scientists of his kind. And then you have the next generation. You have Steve Weinberg and Shelley Glashow. And what happened was that the Jews who came into physics, not all of them, but some of them became the excelled and became the leading physicists of their day. And that anti-Semitism just went away because of the quality of their work. It was the quality of their work and the quality of their intellects that allowed them to overcome what were real institutional prejudices at the time, institutional prejudices which I would say are much more explicit than any claimed institutional prejudices against race right now. Okay, I cannot imagine, nor would I have ever seen anyone saying, we can't have that person because they're black. It's just not the way. Moreover, while anti-Semitism was true in academia, it was true in society. Racism is absolutely true in society, and has been as a part of America since its creation, and it's a reality. But the way to cure any quote problems of diversity is not to cure them at the level of a professor. That's just too late, because again, and Heather, I don't know whether Heather's talked about this, but I know other people have. The people you're hiring are already very privileged. In general, most of them have gone to first-rate undergraduate schools and graduate schools, and it's not really diverse. Okay, where we have to confront problems of diversity and inequity is at the social level. Is that I lived in Cleveland. You were there as an undergraduate, and Cleveland was a travesty when you were there, and when I came there, the inner city of Cleveland was a problem. And I went into inner city schools in Cleveland. My wife at the time volunteered in them, and I saw that what these young kids had to overcome. Cleveland didn't have a tax base, so these kids in the schools weren't getting textbooks. So when I was chair of the physics department, I made a point of saying, okay, there was a school for the arts right next door, which did serve a lot of inner city kids. We donated all of our old physics equipment to them because they didn't have enough money to buy for even to have a science lab in that school. And so that's where you have to deal with the problems to try and overcome what may look like a demographic inequity or democratic incompatibility, but it's so ridiculous to say 13% of America is blacks, therefore we have to have 13% blacks in the physics department, and because where are you going to stop? You can say, well, what's the percentage of redheads? What's the percentage of people who are taller than average? If you really think those things are significant, and I would argue that what Martin Luther King said is much more important to me, the quality of intellect. And so I think that this notion that there's systemic racism, first of all, it flies in the face of everything I have observed. And people are going to say, well, look, my supervisor was black. Let me make that clear. My graduate supervisor was black. So I've witnessed, and when I was a graduate student in Boston, I remember I was going to move into an area at Boston, Bunker Hill, I guess. And he said to me, if you move there, I won't be able to come visit you. And it really, because Boston was incredibly racist, and maybe still is, but was incredibly racist at the time. And so I've seen, it's not as if I'm ignorant of this. I've been involved at every stage of university levels, and this notion of systemic racism is just nonsense.
Well, it's also there's a natural time lag in that it may not be racist now, and it may have been racist in the past or more racist.
Let me go back to your favorite subject, the Nobel Prize.
Yeah.
Okay. When I was at the Nobel Prize ceremonies, I'm sure they're not standing by this now, but I wish they were. I was so impressed because at the beginning of the ceremony, there was one woman on the stage, one woman who won the Nobel Prize. And the head of the Nobel Committee said, you'll notice that there's one woman winning the prize. Okay. We hope that will change. But Nobel Prizes are generally given for work that's 30 or 40 years old, whether you like it or not. And like it or not, that's the way, there were very few women in these areas. We hope that 40 years from now, there'll be as many women as men on this stage, but we're not going to impose that now because there is a time lag. And that's the point. There will be, as in each, it's as each barrier gets broken, as you overcome social inequities, those will feed into the system. But again, here's where I'll get hate letters. Well, I get them anyway. Maybe you'll get them now too. But when people say, when I look at gender in academia, and again, I hired the first women in the physics department when I was chair at Case, and but when people say, well, look, there's more women at the assistant professor level and not as many at the full professor level. And you say to yourself, well, why is that? One of the reasons is there weren't many women on the faculty and there weren't many women in that stream before. And to get to the full professor level, you have to have been an assistant professor. So you would expect in an evolving situation to have a better demographic at the assistant professor level than you have at the full professor level because things change. And that's but somehow to say no, we need to bean count at the full professor level because it's not the same as it is at the junior faculty level is just to misunderstand how academia works.
And I often feel like there's this tautological, again, Ouroboros issue, with Ibrahim X. Kendi and to be anti-racist. And one of the things you probably don't miss about academia is that, how much of our time is dedicated to the unfalsifiable accusation that we are racist, and I've had 8 black scientists, and I don't have them on because they're black, Lawrence. I have them because they're awesome scientists, and I want to talk to them. As I said, I don't have anybody on that I don't want have something that I want to learn from and converse about. And so it's not about and we point out
academia. Look, I'm so happy to have retired because I really do think in the United States academia is largely a lost cause right now. The quality.
Well, I want to ask you about that.
Is just going to, compared to the rest of the world, is going to continue, I think, to be challenged. Let me put it that way.
The one thing I do love about academia is not only for me, but for my children and my wife, we get exposed. I mean, I had students, Lawrence, from Uganda, Saudi Arabia,
me too.
Every continent, including Antarctica, which I don't know if you had any students from Antarctica. But the point being that
you didn't have any students that grew up in Antarctica. I'll tell you that.
Okay. I have one that might have been conceived on Antarctica.
Well, I'm
not going to talk about that.
Yeah. Well, that may have happened, but
but certainly in experimental physics, I would love nothing better than to discover an island that Harvard hasn't discovered. Where there are African American citizens.
That's why United States. I've written about this in a different context when I've written about politics. When people talk about immigrants and immigration. When I've written to try and encourage and not discourage them from allowing Chinese or other graduate students to come to this country, and I'm not the only one who's done it, but the reason the United States continues to, for the moment, to be dominant in many areas of science is because we're able to recruit the best young people from around the world, some of whom stay in the United States, and some of them go back to their countries and do good things. And when that stops, then when they go to other places, and I can see it's happening now already, the primacy of the United States will decline because it's only been both the gross national product and the quality of American educational institutions and research institutions has only been possible because it could, if you want to use your term, poach, because it could attract the best young people from around the world, some of whom stay.
Yeah, I saw, a recent post from, I think it was from Cambridge, University, and it was, taking Newton, not calling him Newton's laws, and how do you teach them? And then they were showing in Beijing, here's your Isaac Newton's laws of the universal gravitation. Or my favorite thing nowadays is, 2 + 2 = 5 can be correct because the notion of right or wrong is somehow
I've written about that. White
Lawrence,
supremacy.
You know this as well as anybody.
You're in California. That's where they're talking about it. In fact, by the way, that's
exactly.
where
getting rid of calculus and getting
rid of advanced placement, AP classes because they're inequitable. It's just ridiculous.
No, I agree, and that's why you're kind of a mystery to me because. But I do want to say, as well as I do, that some of our best students that we've encountered come from, say, from Nigeria. I've had phenomenal. So, not one university. I looked at this. Not one math department in Nigeria teaches anything other than 2 + 2 = 4.
Yeah.
So, in what sense is it? And anyway, I would love the one question. If I could ask Ibrahim X. Kendi one question, it would be, "Why are you an anti-Semite?" Why are you not doing anti-Semitism?
Actually, I'd ask him, why are you a racist, is what I'd ask.
No, he'd say he's not because he's doing anti-racism.
No, he's
not
a racist.
doing anti-Semitism. He's definitely not doing any
you're absolutely right. When it comes to Judaism, I have to say to this, I really identified as being Jewish until recently because I'm a well-known atheist, among other things, and Judaism largely means very little to me. Sorry, because I know you're more religious than me. But because of the anti-Semitism, and I've seen it happening with me now too, but because of the anti-Semitism that's happening, I suddenly want to identify more as being Jewish because of just my natural contrarian tendency.
I want to talk about your article, which was "The Ideological Corruption of Science" is the headline in the Wall Street Journal, and you open up by talking about the American Physical Society, whose president is now my good friend Sylvester James Gates,
who I've known,
who not only has been on my podcast, but his daughter's been on my podcast. She's the second ever African American female to graduate from Harvard University, a place you were a fellow.
You mean in physics? Not to graduate from Harvard, in physics.
PhD in physics. PhD physics, African American woman.
I knew Jim Gates, by the way, when I was a student, and so it was when he was at Harvard and I was at MIT, and then we were at Harvard in the Society of Fellows. So I've known him for a long time.
You wrote this in 2020, and in the summer, following the George Floyd killing, et cetera. And the title of a video kind of above it is "Opinion: The Left Consumes the Left." So everything you're talking about, if I just covered up your name and your Twitter profile and some of your past interviews. People think you're like a rabid, right winger or, conservative now, like everything you're aligned with. And people like Peter Boghossian, who's been a guest on the podcast and as a friend, and Noam Chomsky. You had a conversation with Noam 3 weeks ago on Origins podcast that was just, really shocking, terrifying. But it's like, Noam, I didn't you call the Republican Party the greatest terrorist organization on earth? It's like, and I'll talk to anyone.
No, I've been called a right wing pundit now, which breaks me up as someone who's always thought of himself as incredibly left wing.
I've had on my show, I've had Ben Shapiro and Michael Knowles, probably people you don't care so much for. I've had
I've become much older and more tolerant as time goes on.
I want to ask you about Judaism because you brought it up, and I'm going to ask about it. I often use you, and with the utmost respect, Lawrence. I always say, Lawrence is so bright, but when it comes to Judaism, and I haven't pointed out, I don't send you typos and things like that that I find, but. If my 10-year-old comes up to you and says, "Lawrence, I found that Professor Krauss," he'd be very respectful, unlike his father. But anyway, he'd say, "Dr. Krauss, you are amazing. But, there's logical flaws throughout a universe from nothing and are, philosophical or even mathematical." You'd say, "Get out of here, you 10, 12-year-old kid. You don't know anything. You don't have enough experience generating wisdom. You might have Wikipedia."
Well, I don't think you'd say that, especially with a 10-year-old. I'd want to hear what they have to say. It's the adults I'm not so interested in.
My 10-year-old will blow your mind.
Okay, fine. And I love when kids come up with things. It's the adults that bother me.
Yeah, the thing I'm getting at, Lawrence, is that I want to know if you're anti-religion, if you're anti-Christian. I don't really care so much about that. But the point I'm trying to make is...
I'm not anti any of that. I'm an apatheist.
Yeah. So
if God means nothing to me.
Right. So, and you talked about this with Woody Allen on your show, and he's famous for saying, I'll settle for a divine sneeze. My point that I'm trying to make is that your education in Judaism, to the extent you had it. Now,
I was bar mitzvah.
I didn't have. You were bar mitzvah. I was just going to say that.
Okay.
And that was probably the culmination of your. I wasn't bar mitzvah.
That's when you weren't. Okay. See, for me,
I wasn't. I was an altar boy.
I want you to know that turned me into an anti-Semite for a while.
Yeah.
Bar mitzvah. Okay.
Exactly.
Yeah, the whole experience was so disgusting that I wanted nothing to do with it for the longest time.
As it did for my father, who was a militant atheist himself, a term you coined, I think you coined, and are proud of. But the point I'm trying to make is that
I've argued that militant atheism is a oxymoron. What does it mean? You throw papers at buildings? I don't know what it means. Anyway, but okay.
Militant pacifist.
Yeah. Anyway.
But the point is, your formal education, might have culminated with your bar mitzvah. Probably certainly did. I didn't know that you were turned off from your from Judaism at that point. But in other words, what about you? And one of my audience is asking this question: what about Jesus, the most famous Jew who ever lived? Are there things about Judaic faith that are emulatable? Are there principles? Are there is there redeemable aspects of it, or is the entirety of it shaped by this experience that you had as a 12-year-old, 13-year-old?
No, look, first of all, I was growing up to revere this. My mother convinced me that being Jewish involved questioning and wanting to learn and all these things, which I buy into that somewhat. I mean, I don't think it's certainly unique, but but I think the notion of questioning, the Talmudic notion of questioning is wonderful, because for me, questioning is everything. So I'd say if I had to pick one sort of thing that I really do think is culturally Jewish that is enviable, or that derives from the religiosity, which isn't enviable, it's the Talmudic basis of questioning, of trying to work through questioning, because that's the basis of understanding. So I would say that that's a very noble thing, but the rest of the whole religious basis of Judaism I find completely ridiculous, and the notion. But having said that, I will point out that I'm no expert. And in fact, I may know as much about Islam as I do about Judaism in some ways.
I was just gonna say, do you know? I call you, when you're not around, behind your back, I call you a devout Israelite, because not a Jew, but you know what the word Israel means in Hebrew. Do you know?
What does it mean?
It means fights against God.
Okay, yeah.
Because Jacob, whose name would later change to Israel. Anyway, it's the notion, and it's the opposite is Islam. What does Islam mean in Arabic? It means submission. So they're completely diametrically opposed. One is submit to God completely, and the other one is to fight and wrestle with, as the Talmud does.
Yeah,
and
well, in principle, yeah, but let's not pretend that the Old Testament isn't as violent and horrific as the Quran. I mean, stone your children if they disobey you. I mean, it sounds nice, but the difference is, and I would say that, and again, it's not a very profound or deep intellectual study that I've done in this regard, but the difference is that Islam is 600 years younger. So 600 years ago, they might take that nonsense literally and do the worst possible things. And now we say, yeah, but okay, we don't, that's okay, but we don't buy that stuff. We have a kinder, gentler religion now. And so I just think part of the problem of Islam is that they're in the phase of taking all the nonsense literally, including the invective, including the hatred and invective. That's
let me just say about
endemic to all sacred texts, including the New Testament, I would argue.
Let me just say about the stoning. So that's very interesting, and I wasn't planning to go in this way, but I do want to point out that so what the stoning says is that the parents may not stone their kids. And they're big deal. But back in the ancient world, as is in the current modern world, the notion of honor killings was predominant. Yeah. For the first time in human history, Judaism took the power to kill your child out of the parent's hand. Now, the parent has to take the child to the Sanhedrin, then the Sanhedrin, there's no record. And the Talmud, the Germans and the Assyrians, everybody has used the Talmud to skewer the Jews, because there's no book that's more anti-Semitic than the Talmud, saying how awful we are and how bad. But anyway, Lawrence, the point is, and same with divorce. People think of the treatment of women, and it's true. But there was a first time in human history when a woman could be an agent and be self-deterministic and could get a divorce. And if the man did not give her a divorce, he would get stoned.
Well, it's matriarchal. Well, they were smart. I mean,
it was very patriarchal.
There's a good reason to be matriarchal. I mean, the one thing about the Jewish religion is that I've always enjoyed is that, or at least appreciated, it seemed to me, or at least the culture, is that it's based on thinking intelligently about how to get around things, and it's smart to be matriarchal, because 10% of fathers aren't the fathers, and you know who the mother is. And but look, I'm not saying that. Look, these were ignorant pests. These were to the extent that the Bible was written in any time, it was a time of A, ignorance, and B, violence and hatred, and it's characteristic of that. So understanding that is not to demean the Jewish religion, which arose out of it. It's just to say it came. I mean, we shouldn't revere these ancient books that are really written at times that happily science and other things have allowed us to overcome.
Although I think Shakespeare is quite excellent, and those times were times of endemic poverty and ignorance and illiteracy.
We look for what we do, and I've always been a student of history, and actually, anyway, first book I was working on was a history book, but the we should appreciate and understand the history and the wisdom of the fact, because basically things don't change. The more things change, the more they stay the same. So it's worth looking for the gems of wisdom in Shakespeare, and it's worth looking in the Bible for things that are gems of wisdom about the human condition, perhaps.
Yeah.
But it's not worth claiming it's a sacred text any more than it is to say Shakespeare's, because some of his plays stink. Okay.
Yeah. No, that
and so
you're saying it's not a
sacredness is an anathema and that's the problem. And so I guess I grew up in an area. You see, grew up in an area that was completely Jewish. I didn't know there were. I thought Jews were the majority till I was 12, and then I moved to an area where there were no Jews. But I was always brought up with this kind of effete view that somehow it's something special and wonderful about Judaism, and I guess I try to rebel about that. Of course, I appreciate the many of the cultural aspects, but I also understand that there are other equally laudable cultural aspects that have nothing to do with Judaism.
No, I just always do rail against. I mean, there is my dream is to adopt the Havrusa mechanism with you, where the two partners sit down and they take one sugya, one passage, one equation, basically, and they just beat each other up about it. And the goal is not to look. During the Holocaust, there's famous stories about modern rabbis.
By the way, that's the way I have always proceeded my research with my students. That's and the way it was when I was with Shelley Glashow when I was at Harvard.
Yeah,
you sit in a room and you argue and you complain and that's fun.
Yeah. And there is wisdom. I asked Ann Druyan, as I'm going to ask you in about 10 minutes, the immortal words of wisdom that she wishes humanity would adopt. And she quoted from the book of Micah. And she's a devout atheist, as you know, and Carl Sagan, a humanist, rather.
I know her.
And she quoted, and except for, act justly, love mercy, and that's it. The last word, for those of you who don't know, in Micah is walk humbly with your God. But anyway, I do want to ask some questions from my audience. But before I do that, so anyway, my dream, if we are together, is to take you to a Shabbat dinner, because it's almost impossible not to enjoy that. And second of all,
I've been to many
study
Shabbat
the Talmud
dinners
together.
Yeah.
Yeah.
My favorite when I was at MIT as a graduate student, I guess when I was alone and I thought, well, okay, I may as well explore my roots. I went to Passover Seder put on by the rabbi, whatever the official people are in at MIT. I forget what that group is called, but anyway,
Hillel,
that's right.
Yeah.
And it was a really enjoyable experience. One of my favorite things was the detailed question of, he held a wine glass. This isn't a wine glass. If this were empty, well, maybe no.
Yeah.
Well, maybe. Hold on.
I got a Scotch bottle.
This one from the. So the rabbi said, why do we hold the wine glass like this? And everyone was discussing it. And he said, because if you hold like this, all the wine goes out. And I thought that was anyway.
Yeah, that's right.
Okay.
That's right. Yeah, I mean, for me, it's much more practical. It's very hard to imagine that, secular. And I've spoken at the Ethical Humanist Society of Chicago, which is one of the foremost, oldest.
And I've spoken at churches and synagogues. The one synagogue I wasn't allowed to speak at was an Orthodox synagogue in Cleveland, because I indicated them that I was going to say the world was more than 6,000 years old, and they wouldn't let me speak. But anyway,
so I personally don't know, and I believe that, but the rabbis that I traffic in, and
of course,
this is not something that because we can get into that on our next conversation.
Okay,
but now,
sorry, I'm distracting.
I want to first ask you about hype. So we talked about hype, but I want to ask you about artificial intelligence. The claim is that artificial intelligence is going to eventually produce, artificial Galileo. And I've actually worked with, since I now have the text, 1 million words of his dialogue in printed form, for the first time to make the audiobook, I am going to put it into GPT-3 and see if I can teach him QED or, whatever, but to just see what will come out of it, because I think it'll be interesting. But my assumption is that just because computers can beat any human at chess, it doesn't mean they can create the game of chess. In other words, they can solve a Rubik's Cube. Can they invent a Rubik's Cube? But in the essence of physics, the claim is that it's just Max Tegmark has written about this. It's just a matter of time before we have artificial Feynman. And I claim that will never happen because
first of all, okay, go on. Let me.
I was just going to say when Einstein. Do you know what Einstein called the happiest thought of his life? Not fantasy, but the happiest thought of his life, Lawrence.
I seem to remember it, but remind me, as I know sense.
Was that if you were in free fall, you'd experience zero acceleration.
Yeah.
So gravity would be equivalent to acceleration. He called that now. How can a computer, and that's what led to GR, in some sense. How can a computer know what it feels to free fall, B know what happiness is in this context, and C, how can they take that intellectual leap? If you're just taking data from Newton and showed the perihelion of Mercury anomalously advances, how would you possibly get from that lacunae in the data to a new way of thinking about a fundamental force? So those are my opinions. What do you think about
I think you're being short-sighted, but I also think these other people are being ridiculous. I mean, first of all, anytime you hear people predict things about things we don't know anything about, they call themselves futurists often. That's when those are people you shouldn't listen to. And almost invariably, they miss the important stuff. I mean, we were supposed to be in flying cars, when in the 1950s, but when they talked about 2000, but they didn't talk about the internet. But I think what's clear is that you're making presumptions based on the present of what. Well, first of all, we don't even know what intelligence is in some deep sense, but you're making the assumptions that I can't input all of the sensory data input that you'd feel in free fall, and you're so for me, I see no barriers ultimately to what you would call an artificial consciousness, but it's not. The problem with artificial intelligence is not artificial in any sense.
Yeah,
it's really mimicking in some way the intelligence that it's creating an electronic version of a system that arose haphazardly by biology, and biology did it very effectively because it had a long time to do it. So I don't see any barriers to ultimately what you would call computers being conscious. I ultimately don't see what computer Feynman is not the way of putting it, but what I am interested in a general artificial intelligence in those using those language which I don't like, precisely for the same reason I think that Feynman was, which is I would like to know what an intelligent computer, what physics questions an intelligent computer would find interesting. And it's not at all clear to me that they'd be the same questions. To me, it's just like wanting to know about an alien intelligence. I would love to have an alien intelligence because I'd like to learn a lot about what they've learned about the world and how they think about it, because it would illuminate, presumably, potentially a completely different way of thinking about the world than I'm used to. So I don't see it as a threat in that sense, nor do I see it as a panacea. I see it, I think, in the long run as kind of inevitable, but not in any, but I mean long run. I don't think AI is an area that's incredibly hyped. You're absolutely right. Computers can beat people at chess, but robots can't yet really effectively fold laundry. And so, this notion of, around the corner, that's going to happen, I think is ridiculous. But I personally don't see it as a problem. And the example, I wrote about this once in an article that was going to be in a book, but they removed it on AI a few years ago. Anyway, it doesn't matter where it was. I find it fascinating that Plato and others, going back to Plato and in full circle, around the time that writing was first invented, totally decried writing because they said it would ruin storytelling. Storytelling would be over because people wouldn't have memories, they wouldn't be able to do this stuff. And of course, it didn't happen. So what it did is it changed things. And I think that as computational systems become more capable in different areas, it will change things. But I don't see I guess I don't see the same barrier. I think you're just imposing the present on the future. Who knows what the origins of creativity is, except it's making connections at some level between disparate things in some way. I don't see any barrier ultimately to a computer with sufficient input from a variety of things to be able to not understand how happy it is to fall in the absence of gravity, or even sense it in any sense that we sense it. Because I was just listening to a wonderful. I like Bill Bryson a lot, and I was listening to his book on the body, and he points out a very important fact that we feel pain everywhere we feel pain in the brain. Okay,
Yeah.
not in the fingers, not the ones that are being burned. It's in the brain that it's created, and it's created because of a whole bunch of biochemical reactions that relate to sensory input. And I don't see that electrochemical reactions or electrical reactions related to similar sensory input can't create the same feelings in that artificial brain. But that's my opinion.
Yeah.
Okay.
Yeah, I've thought about that. If you want to teach them pain, blow a capacitor here and a resistor there, right?
I mean, it's a mechanism that was developed, and so why wouldn't they? I mean, they may not. Who knows? I mean, it's this fundamental philosophical question, which none of us can ever really answer. Which is, how do I know that your pain is the same as my pain? How do I know that your green, even though I'm colorblind, that your green is the same as my green? And anyway,
I'm writing a new book. What is it like to be Thomas Nagel under the pseudonym A Bat? My nickname, my name is going to be A Bat.
Yeah.
Okay, Lawrence, we've reached the lightning round.
Okay.
First, I'm going to ask you some questions from my audience. Then the lightning round. Then we're going to close up.
Good,
with
because
my
wife is going to be very angry because we were going to go
right,
kayaking out at the river behind our house in a moment.
All right. So this could be a lightning one-word answer. Is Jesus Christ a good role model? From my viewer, Immanuel Kant. Immanuel Kant is my
wow. It's very wow. He's for a dead guy. He's very very prolific. But
so is Jesus a good role model worth emulating? He asks.
Not particularly. No. I mean, some of the things. Look, I don't know what you mean a role model. I think that
whatever it means.
No, I mean, he said certain things. He's purported to have said certain things that are certainly worth appreciating and respecting. But yeah, no, I'm not. No, not particularly.
Okay. Would you like to sit down and have a conversation with your fellow countryman Jordan Peterson?
Oh yes, and I have, and I will.
Okay.
Yeah,
great.
in fact, I have. In fact, for this, I just had a long conversation with Jordan Peterson that's going to appear on his podcast Monday, I think, and he's going to be on mine. Yeah, wonderful. Because I'm become very magnanimous as I've gotten older.
Yes, that's right. You've mellowed, man. You've changed, man, since you moved to Canada.
Yeah,
the great mellow north.
Well,
next question.
Age will do it. Anyway,
do you feel like it was fair of your assessors to fail you in your first PhD Viva on the basis that he knew maths but not physics? This comes from Rajiv Ganjel. He recently said, although it was traumatic, he learned a lesson.
Oh, absolutely.
Do you think it was?
Yeah, absolutely. And it was incredibly important because because physics is phenomena, and if you're not in touch with phenomena, you're not doing physics.
Great. Easy question from listener AJ. What happened before the Big Bang?
My answer is potentially it's a bad question.
Okay. How can an average person...
And for the reasons I said earlier, time may not have existed, so that's not a good question.
Yeah.
And the other answer is, I don't know, which is an answer that we should all use more often to almost all questions. Sorry, go on.
Should we trust the same government that makes us, has missed COVID at first, denied it, then has gone into complete, opposite direction? Should we trust the same government that enacted various suppressive and also amplification of information? Should we trust them to tell us what to do when it comes to climate change? Which we didn't get to talk to, but we.
Yeah, you didn't. In my new book, you didn't even plug
I'm going to plug it. I will plug it. I'll give away a copy. How about that?
No, but we didn't never trust anyone. No one. Look, that's the reason I wrote the book. Point is, educate yourselves, at some level, and as the point of the book, almost anyone can understand the fundamental science behind climate change and the really basic predictions. It doesn't require supercomputers to understand the basic science behind climate change, and it's fascinating science. And my point, there's no policies recommendations in my book. The point is to say that that policy, first you have to understand reality, and then you can decide on policy. And so the point is that never, obviously, don't trust anyone. Try and understand it, and then impact on government, because what governments never do is lead. What they always do is follow. And I learned that from Noam Chomsky when I was a graduate student about Vietnam. Ultimately, what governments will do, how the way governments respond to climate change will depend upon the public, and it will only be rational if the public has a rational, ultimately rationally demands policies. Okay. Anyway.
Got it. Next question comes from Lucas Pattison, who asks, can we sacrifice our politicians to an active volcano to save ourselves from climate change? And if so, who would you choose? Active politician. It has to be an active politician, active volcano.
Let me just say this. Politicians are politicians, and that means they have very specific jobs, and of course, part of being a politician involves doing things that a lot of people would not want to do in order to get elected. But I will say this, and maybe because I'm influenced, because I was just speaking to a congressional aide the other day, one of the things I'm very proud of is in my foundation, and I'm not profiting from this in case anyone figures out, but we sent copies of the book Physics of Climate Change to every member of Congress, raised money to do it. And because why? Because we want them to just, again, it's not a Democratic issue. It's not a Republican issue. It's not a left or right issue. It's just a science. And then they can decide on policy. But I've testified before Congress, officially on one occasion, me and Buzz Aldrin many years ago on the future of space exploration. I've lectured, I've given what I forget what they're called, briefs before Congress and congressional aides. And every time I do it, I come away more impressed with the people working hard on behalf of people than I am when I listen to the news or watch the news. So I will say that on the whole, in Washington, there are many people, and in Canada, in Ottawa and other places, there are many people working very hard on behalf of what they think is right. And so let's just say that.
That's helpful. And that reminds me of a joke. What's the opposite of the prose of something?
The poetry of something?
No, the pro.
No, I know. When you said prose, you didn't get my joke. Okay.
I got the prose.
Okay, anyway, what's the opposite of prose?
What's the opposite of pro?
We're finished. It's almost finished. Mm-hmm.
Yeah. What's the opposite of pro? When somebody says you want the pros and the
cons, obviously.
Right. So what's the opposite of progress?
Congress. Okay. Yeah.
All right. Good. All right. Last couple of questions. I know you're busy. Apologize. Blame it all on me. Some.
Can I tell? Now I was going to tell you. Now I have to tell you my one joke too. Okay.
Go for it.
Because it's related to your questions about Judaism and the questioning thing. You probably know this joke about this grandmother takes her grandson to the beach, and he's sitting there, and he's playing at the beach with his ball, and a big wave comes up and swallows him and takes him out to the. And disappears, and she looks up. She goes, God, please, he's a wonderful young boy. He shouldn't end his life this way. Please, don't kill him. The big wave comes back and lands him back on the beach. And she looks up and says, he had a hat. Anyway,
all right, okay. Lawrence. Well, we have reached the end. Now I have the final three questions. Okay. If you'll indulge and give me some of that good Christian forbearance that you're known for. And these involve things related to Arthur C. Clarke, who is the namesake of the center at which I co-direct that hosted you many years ago. And the first one is going to take us to the biblical age of 120. And it involves a so-called ethical, not material will, but your ethical will. So Alfred Nobel had partially established an ethical will by ensuring or hoping to enshrine that the benefit to mankind would be the greatest accomplishment of the laureates. So anyway, so he had one. The famous ones go back to Jesus, and Barack Obama wrote an ethical will. It's called a Zava'ah in Hebrew. Anyway, what would you like to convey in wisdom or knowledge on ethical imperatives when you spring forth this mortal coil at the biblical age that Moses achieved of 120 years?
That's a question I can't answer. I don't really think in those terms. I have no, I have no, I have no legacy, or if you want to, that I would want to leave other than the work that I've done during my life. That's all.
Okay.
Nothing.
All right. Next question involves a monolith spotted in 2001: A Space Odyssey, which is some kind of a time capsule.
Yes.
And this question relates to Feynman's question of if in some cataclysm all scientific knowledge would be destroyed and only one sentence passed on to the next generation of creatures, what statement would contain the most information in the fewest words? You wrote a book about it called Atom. That was his answer. What about humanity discoveries in physics is most impressive that you would use as sort of a talisman to put on a billion-year-long Arthur C. Clarke-like time capsule?
Okay, let me. This is going to be a problem with all your questions. It's a fundamental. It's a personality problem of mine. Maybe you can call it character trait. I don't think hierarchically. I never have. So I don't think of most this or most that. I like a lot of different things. So I rarely list my favorite book, my favorite one. But so to pick one thing. But what you say, what thing would I put on a time capsule?
What piece of information about the physical universe do you feel encapsulates the most amount of information in sort of the most compact form, as Feynman said?
Yeah, Feynman wrote about that at one point. What he'd put in
the atom.
Yeah. Actually, I think I could have argued something else. I might have said the statement from Galileo where he says, "But yet it moves," would maybe be because from there you can build all of physics. So it's the seed from which all of physics builds. So that's one thing I might say. But I think the other thing I would say, and I've written about this for undergraduates actually, is the Hubble constant, the expansion rate, because basically every major feature of our universe comes from that one quantity. You can understand the age of the universe, almost everything from that one-dimensional quantity. So the expansion rate of the universe is, in my mind, the most important global quantity describing the universe. Okay.
Excellent. All right. The last question, Lawrence, relates to the title of my podcast, and that is a saying of Arthur C. Clarke, which takes us backwards in time. He said, "The only way of discovering the limits of the possible is to venture a little way past them into the impossible." And that's the origin of the name of this podcast. But I want to ask you, going back in time to a 20-year-old, 30-year-old Lawrence Krauss, is there any advice that you would give yourself to help you have courage and so forth to go into the impossible?
Well, as I say, I mean, my job has been to think about the possibilities, which means to find out, how to turn the possible into the possible. So that's what my job has been that way. But the advice I'd give myself, and I tend to try not to give too much advice, would be the same advice I always give young people, which is don't let the bastards get you down.
I think I had a T-shirt like that when I was a kid, except it was turkeys and I was an elephant, but I didn't wear it because I got teased for being fat. Lawrence Krauss, director of the Origins Project Foundation, a nonprofit which can be accessed at the websites in the video description below or on the text audio description. Also the proprietor of the Origins podcast. Lawrence, has been fun. We should catch up more often than every 9 years.
Yeah, wow. It was truly delightful. I wouldn't have spent 2.5 hours with you if it hadn't been. And I'm pleased that you did your homework, which is always, to me, the first step of quality. And so, but it was great. Yeah, I kind of miss you. I'd like to. Yeah, so I should come
That'll be fun.
I should come up there. You're not allowed here right now because
I know
you have to be quarantined like I am. Anyway,
they're spiting us. All right, Lawrence, have a great day. Sorry I kept you so long. We'll probably break it into 2 episodes.
Okay.
Have a wonderful rest of your day.
You'll have to apologize to my wife more than me.
I will. Just send her my way.
We haven't missed our opportunity.
San Diego too.
Yeah. Okay.
Tell you what, Lawrence, when you guys come and visit in January, I'll probably be able to make it up for that.
Okay. Yeah. Okay. Take care.
Bye. Be well.
Okay.
Thank you.
Any sufficiently advanced technology is indistinguishable from magic.
If you enjoyed this video, I know you'll want to check out my interview with Frank Wilczek, winner of the 2004 Nobel Prize. In this conversation, Frank and I discuss his fascinating new book called Fundamentals, which outlines 10 key principles to understand our universe. And don't forget to subscribe.